Hello everybody, Chris here, and in this mini-series I want to show you guys how to set up a simple four-directional gatherer RPG. So one of the first main things I want to focus on is how you can get a character to be able to walk around with four directions, and also be able to attach an item like a axe or a pickaxe to a location on the character, and be able to have it animate in all of the directions. So in this demo, I also have it set up so specific types of tools are going to work on specific resources. So if I take a swing at the tree, we'll see that some items pop out. So these are emitted as particles, but when they reach a certain radius, they're going to turn into game objects, which is another thing we're going to be focusing on. And if I switch to the pickaxe, we can see I can go over here to the rock, and we can harvest rock items. So the harvesting mechanics obviously going to be a big focus here, being able to go around and collect the items. And you'll notice if we take a look at my resource inventory that we can collect different types of resources, which will be added to a dictionary down here that keeps track of how many we have collected. So we'll be setting up some simple particle physics, like having a following trail of particles left behind as the player walks, but not when the player stands still. And we'll be utilizing a few different packages, including Cinemachine for a follow camera, the modern input system for handling basic character movement. So the art I'm going to be using for this series is my own. It's the Gatherer's Exterior pack, which you can find on itch.io. So my pack, which is completely optional for this series, includes the Tilesets objects, the walking character, C# scripting as you saw in the demo, and all of the prefabs necessary for adding objects to your scene, such as the Harvestable, trees, and rocks. But really, all you need to follow along is some kind of top-down tile set and character to go with it, as well as some objects. There are plenty of free options on itch.io if you prefer to go that route instead. So in the first couple of parts, we'll work on getting... So to start setting up our project, I'm going to have Unity Hub open, and we're going to go over to New Project. I'm going to be creating the project with the newer version of the 2022 editor, just so that we're using a modern version. And you have the option of choosing a new project with the basic built-in 2D renderer or the 2D URP universal render pipeline. So the main difference here is that if you want your sprites to have lighting at some point, then you would need to be using the universal render pipeline to support 2D lighting. But generally, I just default to using the universal render pipeline by default when I'm doing any kind of top-down 2D game. So for the project name, let's call it Gatherer Top-Down RPG. And I'm just going to put it in my folder that holds all of the tutorial projects that I've been doing recently. So let's select that as the folder, 2D URP, and I'll create the project. So once again, the art pack I'm going to be using for this series is my own, the Gatherer's Exterior pack on itch.io. You can use basically any top-down tile set in any character you want. There are free options available if you take a look for them. And I have a complete demo that basically has all the mechanics that we're going to set up in this series included on that pack. For the series, so that I can demonstrate how you actually do everything, I'm going to be starting just using the art assets and nothing else, and then we'll go ahead and create all the scripts and prefabs and so on in this series to actually make those things happen, like moving around the screen and harvesting the different objects around your game scene. So if you do want to follow along with exactly the same materials, I'm going to be using the art-only version of the pack, which only has the PNG sprite sheets, and then we'll build all of the other stuff that you see and what you would have in like the Unity project version of this asset. So with the downloaded art, I'm going to extract this to the desktop and not bring it into the project just yet. There's one extra step I want to do. So I'll just bring that there to the desktop, and when we're ready, we'll import it into the project. Because this is a pixel art pack, so it's based on a 16 pixel by 16 pixel grid. Pixel art also shouldn't have any filtering set up so that it's not blurry when you're trying to show it inside of a Unity game. So what we can actually do is set up a preset for a texture importer. So the easiest way to get the presets to show up here in the inspector where we can edit them for a texture file would be to bring a actual PNG texture into here. So I guess I'll go into the Gatherer's Explorer pack, and let's just grab something from here. I'll just go into Tools, and let's grab a Copper Axe PNG, and I'll just drag that in here. Okay, so now I can just, for demonstration's sake, pull this into the scene, and you'll see a couple things. First off, it's really, really tiny because the default Unity grid has 100 pixels by 100 pixels for every unit of game space. Also, if we keep zooming in, and I'm using middle mouse scroll to do this, so we can fix both of those by clicking on the PNG art asset, and you'll see that this is a texture 2D, and we need to change the settings here and then create a preset from it. So first off, to get rid of the blurriness, take filter mode and turn it to point, and down here for compression, turn that to none. If you hit apply, it should now be fixed. All the pixels should render crisply. The other thing, pixels per unit, is up to you. So the default is 100 pixels per unit. Makes it easy to understand for the art across your game in the sense that if you change the value by 0.01 unit, then you know that that is 1 pixel, or 0.1 is 10 pixels, and 1 unit is 100 pixels. The pack I'm using, Gatherer's Exterior, uses a 16 by 16 grid, so you might prefer to change everything to a 16 pixels per unit grid and hit apply. If you do decide to do that, you have to do it for all of the art assets across your game, or things won't be scaled with each other properly. That's pretty easy to do with presets. But I think for this tutorial series, I'll actually just stick to 100 pixels per unit, since that's the standard and it's probably easier to understand in terms of unit sizes. So let's hit apply, and we'll just have a really big grid compared to the objects in our scene. So with these settings, let's create a preset from them. If you go to the top right hand corner of the inspector, you can click here where you have the 2 slider bars, and you'll get the select preset option. So we want to create a new preset instead of selecting one from the non-existent list. So let's create a new preset, and in the assets folder of our project, let's create a texture importer. I'll call it Pixel Texture Importer to be a little bit more specific, and this is saved as a .preset. So if we save that, you can click here and you can see the same settings we set up here. So if you want to make this the default for any textures that you bring into the game, you can just hit Add to Texture Importer Default. Another place you can do it is if you go to Edit, Project Settings, and then Presets, Preset Manager. You can add a default preset, just clicking here. Put in the type of preset you want to add a preset for. So this would be Texture Importer. And then you can select the preset from the existing list of presets in your project. So if you click here, you can see the Pixel Texture Importer as an option here. Or you can just click Add to Texture Importer Default, which is just a quicker way of doing the same thing. So I'm going to remove the second option here. It is possible to set up filters here to have different versions of your texture importer for like files that would be located in different locations, or maybe have a different part of the file names, such as files that would be tagged in -sprite sheet at the end could be set up with maybe a texture importer that imports sprites into sprite mode multiple by default. Not really going to get into that too much here. I think it's a little overkill for what we're doing. So we're just going to have one pixel texture importer just to have those default settings set up. So now that I have the texture importer defaults, I am just going to remove this game object, the axe, from our scene and remove the axe copper PNG from the project. By the way, I'm sure you've noticed that my layout is a little different than the Unity default. So if you want to use the same layout, you can go to Window, Layouts, and I'm using Wide right now, which obviously makes the Scene and Game Viewer window wide, which works because we're going to be doing a widescreen resolution for the game by default. Okay, so the next thing, bringing the art actually into the project, we can minimize Unity, and I am going to just bring this entire folder over to the Unity. So the next thing we're going to do is actually import our art into the project. So I'm going to go to the desktop, and I have Gatherer's Exterior extracted from earlier. Going to jump into it, and we'll see that I have everything nested inside of an art folder, and inside of the art folder is all of the actual assets. So I'm going to drag this art folder into Unity. So just left click hold on the folder, Alt Tab to switch back to Unity, and drop it in here. So now we have all of the art files inside of here. So I'm going to right click and combine all of these into another folder, just so that this art folder has a little more organization. So I'm going to right click here, create folder. I'm going to call it Gatherer's Exterior, no spaces. And then I'm just going to select everything else here. and I'm going to put it into that folder. So let's just select everything and move it in there. This way, with this project organization, if you add any extra art assets into the art folder, then they can be separated from this stuff over here. Okay, now we want to make sure that when we imported everything, it actually got the right settings. So I'm going to click here on one of the files in the project and just make sure that it is using the presets we just set up. So we can see filter mode is point no filter and compression is none. So the reason I wanted to set up the preset before we bring in the art is so that everything imports with the proper settings the first time and we don't need to manually change anything. So we can confirm this is working by just dragging one of these things onto the screen, and we'll zoom in on it and just make sure that all the pixels are crisp and that there's no blurriness, and that's how we know we are using proper pixel art settings. So I'll just Control Z a couple times and remove that. And we can just kind of go into the folders and just double check quickly, verify that everything is there. And once we've done that, we'll just move on to the next video. So in the next video, we want to start setting up the character for our game. Now, we can't just drag one of these entire sprite sheets onto the screen in sprite mode single. Well, we could, but it would look like this, and that's not correct because we want to only show a single frame for each character at any given time. So I'm going to Control Z and undo that. And what you want to do with these kind of sprite sheets, which have multiple frames, is change them from sprite mode single to multiple. Now you can do this in bulk by selecting all of the sprite sheets in a single folder that need to be in multiple. So I'm going to left click on one, hold Control down, and then left click on all of the other ones you want to add to this list that we're going to be changing at once. You'll notice the number in the inspector goes up as we add extra selected files. So select all 8 here, and then I'm going to go sprite mode single and change that to multiple. Okay, so now we need to take these sprite sheets and separate them by frame. So I'm going to go to the sprite editor, and then I want to go to the top left and hit slice, and you'll see type, which we want to change to grid by cell size, because we know the exact size of our frames across our sprite sheet. So it's 32 by 32 pixels, and by having it set up like this, the number of frames doesn't matter because they're all the same size, so it'll slice it up correctly every time. So let's go ahead and hit slice for right now, and then we'll click on these different frames. So one problem we're going to eventually run into here, if we want to do sorting by Y position, is the pivot point of the character. So right now the pivot point is set to the head, and if we sort by the pivot point, then that means that whether something shows in front or behind the character is dependent on this pivot point. So that doesn't make sense to have it be the head for this type of top-down character, because we're more concerned with where the character touches the ground, which is much more down here at the feet area. So if we walk past grass, we want it to show in front or behind the player, depending on if the feet are in front or behind the grass, not whether the head shape up here, which is technically floating above the ground, is in front or behind the grass. So this will make a lot more sense when you can see it visually, but for right now, we need to move the pivot point for all of our frames much further down below for it to make sense. And I think I'm just going to put it at the bottom here, halfway in between both of the legs, but we can have it kind of snap to pixel if we want. So I'm going to go to the bottom right, pivot unit mode, and change this to pixels. And then let's drag it around until we have it at the pixel we want it to be at. So we can zoom in, and we just want it to be roughly halfway between both of the legs, and that should be good. The horizontal left-right position isn't going to be as important because we're only sorting by Y position, top to bottom. So if we have it roughly there, we can give it a little bit of a nicer number here as the unit value. So I'll do, let's say 0.105, and then for the X, we can say 0.5. Should be fine. And then we just need to make sure that all of the frames of animation for our character have the same pivot point. So I'm going to take the 0.5 and this value, and I'm going to use that when I'm slicing the characters. So in the top left, let's go back to slice. You'll see that pivot is an option here. We want to change this to custom, and then just paste the Y value in, which is 0.105. And then for method, I'm going to change this to smart. Delete existing. Sometimes if you just do that kind of recklessly, you can get missing references to frames or objects in your project. So I just tend to drift towards smart or safe, just so that I'm not accidentally, deleting frames that are actually being used across the game. So let's use smart, slice, and I'm going to hit apply. And just make sure that all of these frames of animation, the pivot is set at the same location for consistency. And we can go to the second sprite sheet. So let's hit X here, save any changes. And let's click on the second sprite sheet, swing down. I'll hit save again so that anything is, any updates we've made is already changed. Let's go to sprite editor. We'll hit slice. And you'll notice that it just remembers the settings we were just using from the last sprite sheet. So custom pivot 0.5, 0.105, and just make sure pixel size is 32 by 32. Hit slice. You can click on the frames, verify that the positioning is good on the pivot, hit apply. And we just need to redo that for all of these 8 sprite frames. So let's just go ahead and do that real quick. Next one, slice, slice, apply, X. Click on the next one, hit save. Next one, slice, slice, apply, and so on and so forth. Okay, and that's the last one. So if we take these individual sprite sheets and we click on the little play button next to it, then you'll see expanded. Each of the individual frames will show here. So those are the frames we're going to use for all of our animations. So let's start by dragging one of the walk frames to the scene, which will be our default idle pose. So I'll just drag gatherer walk right frame 0 onto the scene. Let's position it somewhere around there. And that'll create a game object in our scene automatically. I'll just rename it to be gatherer or player, whatever you prefer. And let's take these gizmos and make them way smaller because they are bigger than the actual character. So in the top right of the scene viewer, you can click here and you can take the 3D icons and you can just shrink them way down. And that should be a lot less annoying. So let's also take the gatherer transform position and just make it 0, 0. So this game object inside of our scene will be the basis of our character prefab. And we're going to definitely want to save that to our project as something we can add to any scene. So in the assets folder of the project, let's create a new folder. I'll right click, create folder. I'm going to call it characters. So this could include player characters, NPCs, enemies, that kind of thing. Let's create that folder, jump into it, and I'm going to drag the gatherer game object from our actual scene into the characters folder. Just left click, drag, and drop, and there we have a prefab. So if we want to edit the prefab, you can either click on the game object in our scene, which is linked to the prefab, and click this little arrow. Or if you don't want to edit it in the scene context, you can just double click the prefab inside of our project. So I actually think it's going to be a lot easier to edit prefabs like this, since it gives a nice blue background, which makes it very easy to see everything going on here, like collider shapes and stuff. But when you're editing the prefab in the scene, like so, you get like this very white grayish background, which actually makes it a lot harder to see stuff like a circle collider. So just a personal preference there. Okay, so next up, let's add in the input system so that we can actually get some up, down, left, right movement for our player going on. So there is the default built-in old Unity input system, and then there is the newer package, which is by Unity, which is just a more flexible replacement for the default input system. So we're going to use that since that's more of the modern approach. Let's go to Window, Package Manager, and I am going to search Unity Registry. So in the top left, where you see Packages in Project, go to Unity Registry. And then I'm just going to type in Input System in the search bar. And we'll see Input System 1.5. You can see very, very recently updated. And let's go ahead and install this. So when you do that, you'll get a little pop-up that basically says that the new input system replaces the old stuff. And this could possibly... And if you already are using the old input system for everything, then if you add the new input system to replace it, then it might make everything break. But we haven't actually used any input system yet, so this isn't going to be a problem for us. Let's just go ahead and hit yes, restart the editor. Okay, so back in the Unity project, if you still have the package manager window open, you can kind of scroll down and see if input system is added to the project. So we'll see a little check mark next to input system 1.5. And instead of having an install button, it has a remove button, so we know it's in the project. And let's go ahead and close that. So now I want to add the input system to our character. Let's do it in the prefab so that it will update automatically across any instance of our gatherer object in our project. So I'll just double click into the prefab, add a component, and let's type in input. Let's see, what's it called? Player input, I believe. Okay, and you'll see a little pop-up saying that we need to have a input action asset. So let's create the input action asset. I'll hit create actions. And I guess for now we can just put it in the main folder of our project. So we could call it gatherer top-down RPG input actions if you want. I mean, I guess, why not? Just save it. And then we'll get the pop-up, which will show us the default action maps. So when we take a look at the action map, you'll see that there's a few default actions set up for player, and there are also actions for movement. So when the UI is absorbing stuff like clicking on a button, that is these kind of things over here. And for the player, if you are doing like WASD to move, we can expand the move action, and you'll see the different input options you have for making this action actually happen. So you have, if you're using a gamepad, you could use the left stick of the controller. If you're using a keyboard, then you have WASD on the movement in order to move your character. So basically, one action can have multiple input options for controlling that action. And then the action itself is going to be looking for some kind of value that you can use in the code. So for move, that would be vector to the XY input. And then in your code, you can have it do whatever you need to, such as move the player. So then down here for the fire action, you can have left mouse button, pressing that, and you can see that different control schemes can use or exclude different input options. So if you have keyboard and mouse, then maybe it only uses the keyboard and mouse option, and the gamepad and everything else would be disabled. So the one thing I want to change here is renaming the fire action to be the use action. The reason for that is that we're not really firing anything, and I think that just doesn't make sense as an action name in our case, but rather we want to use whatever tool we have in the hand, which could be a pickaxe, it could be a hammer, it could even be a sword. So we want to keep it kind of generic, but making sense. So I'm going to rename the fire action to be the use action. Or you could call it use tool if you want to be more specific. And for right now, we can go ahead and hit save asset, close that out. So the input action asset is already added in here. The default scheme set to any, which means all of the controls are going to work automatically. You can just leave that set to any. If you really want to force keyboard though, you could change it to the keyboard and mouse input scheme. Now down here at the bottom, you'll see behavior send messages. So this would mean that in code, if you want to respond to a action happening, then you need to create a function with the corresponding names down here. So for the use action, which we just renamed, it would be on use. Or if you want to have it do something when the character moves, then it can be on move. So we'll just be using this default option of send messages for this series, just keeping it nice and simple. But you can also check on the behavior dropdown that you can do other options like Unity events if you want to manually assign the delegate functions in this inspector kind of view. Or you can do broadcast messages if you also want any script that is a child of the main game object to have something happen when these actions occur. But with send messages, it'll only be the scripts that are attached directly onto this main game object, not child game objects. So for now, we'll just use send messages, which means that in our scripts, we're going to need to create a onMove function and a onUse function. So we need to create something of a player controller script now. So let's add a component, and I'll call it player controller, new script, create an add. Okay, so in our player controller script, for right now, we're not going to need update and start methods, so let's just get rid of that. And we are going to do void on move, and don't make it on animated move. It needs to be called on move. And then as a parameter, we need to get the action context. So I believe that is import action dot callback context. And so this context parameter is how we'll get the actual input, the vector to XY movement for the player. to move around. And then we also should just add in here private void on use. So in this case, we can still get the callback context, I believe, but we're not going to need it because when the on use action happens, we already know what we need to do, which is to swing the pickaxe. There's no further information that we actually need to pull out of it. But for right now, we can just leave it there. And we might get like a notice about how it's never used or whatever, but that's okay. So for the callback context on move, we want to do context.readValue. And the value we're trying to get is the vector2 input. So vector2, and then that's how we're going to get the axis input. So now that we're getting the vector input, I want to assign that to a private field so that we can use that across our player controller script. So I'm going to give it a new field, and I think I'll call it axis input is equal to the vector2. So let's generate a private field. Control period in Visual Studio 2022 to do that, and then we can just hit generate field axis input, which writes the line up here, private vector2 axis input. So now that it's here, anywhere we need to know what direction is currently being pressed, we have that. And so how you know that you're trying to read a value of vector2 type, if we go back out to the input action asset and we look at the move action, you can see that the type here, value vector2, is kind of how you would look at that. So this is kind of how you can get an indication for what you're trying to look for in the actual action value. Now to actually take the input direction and move our player, we're going to need a couple of things. The first is going to be a rigid body. So I'm going to add a component, rigid body 2D, since this is a 2D game, of course. We'll leave it in dynamic mode. I'm going to take gravity scale and set that to 0. Since we're doing top down, the character isn't going to be falling to the ground like it would in a platformer game, so you don't want any gravity. For constraints, we want to take freeze rotation and turn Z off. That way, if something bumps into the character or there's a force acting on our character, it won't make the sprite rotate around over and over and over again like it was a ball rolling down a hill. So it'll always be facing straight up like this, moving left, right. And just remember, I'm adding this to the prefab, not the instance of the object in our game scene, so that it will synchronize all of these components between anywhere we need it in the game. Okay, so that we can see the feet a little better, I'm going to click on the gizmos visibility, and let's shrink the 3D icon further. And we don't need it yet, but let's just add in a collider for our player in advance. So I'm going to add a component, and we'll do a collider 2D of some kind. I think for our character, a capsule collider should do just fine. So we'll do a capsule collider. Now, we don't want the collider shape to be the size of the full character, because remember when I was talking about the pivot, there's only part of the character that's actually going to be touching the ground and touching other objects. So we don't want the head to block an object from being able to go a little bit closer to the player, because the head isn't a physics object in that kind of top-down sense. So what we're going to do with the capsule collider is shrink it way down and move it towards the feet. So I'm going to hit edit collider, and then let's bring in the sides, kind of like so. And I'm going to bring this top bit way further down to mostly the main body area of the character. And you might need to change the direction to horizontal or vice versa at some point so that the different sides can be stretched, kind of like so. Because the difference between a vertical and a horizontal capsule collider is that it determines which side, whether that's the left, right, or up, down, can be larger than the other one. So if you're wondering why you can't make your capsule collider shape horizontal like this, it's because you need to change the direction. So let's just kind of move it sort of like that. And we don't really need to have a big collider, and this is always something we can just go back in and edit later. Just kind of make it like what you would think that the character in general, part of it would be touching the ground or touching other objects with its feet. And that should give you an idea of where the collider shape should be. And I'll actually make it even smaller here. Let's just do basically just the legs. And we'll see how that goes. We may come back and edit this later. But yeah, once again, technically the collider, we only need that for collision, not necessarily to move the character. So you can move a object that has a rigid body without a capsule collider, pretty sure. So now let's go back to our player controller script, and I want to set up some kind of move speed that we can apply to our character based on the directional input and then multiplied by time dot delta time to make sure that it moves a consistent amount between frames, even if the frames take longer or shorter duration to render. Basically just for consistency. So up here at the top, we want to have a field that is going to be exposed to the inspector right here for player controller, so we can set up the move speed value and assign whatever we want for it at any given time when we're editing without having to jump into the script. So the way you would do that is you can have a private field and then serialize it. But we can take that a step further and use a property with a automatic backing field. Let me type it out and then I'll explain a little bit what's going on here. So field, serialize field in the square brackets. And then we're going to have public float move speed get private set. So this bit right here makes it a property. One of the advantages of a property is that we can make it so that we can only set the move speed straight from within this script, but make it so that we can get the value of the move speed from other scripts. And we don't have to have a private set. We could make it publicly settable from any other script by just removing the private bit. But with a property, we have the option to set that. With a field, you either can set it or can't set it. If you were doing a field, something like a private read-only, let's say move speed here, then technically this would prevent it from being changed. But the thing is, a read-only field can't be exposed to the inspector so that you can edit it in the Unity editor. So I think this is more appropriate for what we're trying to do. Now, properties aren't exposed to the inspector, so that's why we need the automatic backing field. So if you put in square brackets field here, it's going to generate an automatic backing field, and serialized field is going to expose that to the inspector. So in one line, we have a property that is linked to a automatic field, and that field is what we edit in the inspector. But when we are trying to access or change the values in code, then we're going through this property. And at the end here, we can also assign a default value to it. So I'm not totally sure what we're going to need for the value, so I will just default that to something like 5F. And we can come back in and edit the default value later if we want. So let's go back to the inspector. We can see the move speed here. I guess the field already got hit with the default value of 0 there. So I would need to manually change it here. If we added another script player controller though, it should have the value of 5 defaulted as proper. So let's change the move speed value to 5 here. Now we have a move speed value, we have the axis input, but we're not doing anything with it yet. So what we need to do with those values is on fixed update, we assign a force and add that to the rigid body of the character so that the character can move in a certain direction. Because it's a physics-based function, we're using fixed update, not update. So we're going to do fixed update here, and I'll just have it automatically fill out the private void part. And for this axis import vector2, let's just indicate that by default this is 0, vector2 is 0. Which means 0x, 0y, until we actually get some input from the player. Okay, so in fixed update, we need to basically figure out how much force and what the direction of that force is going to be for moving the player. So in order to do that, we also need to have access to the rigid body component that's attached to the game object. So let's get the rigid body first. So private rigid body 2D, I'll call it underscore rigid body as a private field. And then let's do private start. Okay, and on start we'll do RB equals get component rigid body. Okay, so this just goes ahead and locates the rigid body component that is on the game object so that we can use it in the script. And now that it's referenced in the script, we can add forces to the rigid body. So let's do this in 2 lines, though we could do it in 1, of course. So we'll have a vector2, and this will be, I guess, the move force. And this is going to be equal to axis input for the direction times move speed. And this is going to be times time dot, we'll use fixed delta time since this should always update consistently. So we'll use that consistent value in order to calculate our move force. So fixed delta time, you can actually change how many times per second that this will update inside of the preferences for your game or project settings. But this should always be a consistent number. So now that we have the move force vector set up, we just need to do underscore rigid body dot add force move force. And then this should move our character that is set up with a dynamic mode rigid body. So let's go back out here and we can hit play. And let's see if we can move it around the screen by doing up, down, left, right. Okay, so we get a missing method exception, player controller dot on move not found. So the reason that we're getting these on use not found, on move not found functions is because we're using send messages behavior. So nothing wrong with doing that, but when I add the callback contexts, that's for using invoke Unity events. So if I change this to invoke Unity events, you'll see that these Unity events require a function that takes a callback context, kind of like we have set up here. But we weren't going to do things that way. So rather than assign the function that takes a callback context, we're going to go back to send messages, and we just want the input value. So let's see, it's going to look pretty similar. So import value, and then we can do value.get. We're getting a vector2. So let's get rid of the read value there. And yeah, that's basically all we need to change. So rather than getting the full context, we're just getting the value from the message being sent. We can do the same thing down here as well, though we don't need any value for on use. So if we go ahead and hit play now, we should see the messages disappear. And if I use WASD to move around on the screen, you should be able to see the character moving a little bit. Now, if we zoom in, it's going to look pretty bad. And obviously the camera is way too far from the character, so that's not going to work. But at least the input is working and the messages have disappeared. So just remember, if you're using Unity events, then you use the import action.callback context like I had set up before. But if you're just using send messages, then you just need to get the input value as the parameter, and you can just get the value.get vector2 for the same effect. Okay, so let's wrap things up for this video by setting up the camera to have pixel perfect. So to do that, let's hit add component for the main camera in the scene and do pixel perfect camera. So when we have the pixel perfect camera set up here, you can go back to game view, and it should look a lot more correct, a lot more zoomed in on the character. We can see the reference resolution. If you want it to be bigger for the character being on the screen, then you can lower the reference resolution to something like 240 by 140, something like that. And you should see the character kind of scale. Yeah, so if I make it 480, it's really tiny. So we'll do something like 320 by 180 by default. For grid snapping, I'm going to turn pixel snapping on so that all the pixels do snap to the grid when it's rendering on the camera. For the resolution, you can see this little error message that kind of pops up here saying that the pixel perfect camera does not work well with a free aspect ratio. So I'm going to change this to another default setting. And what I've been liking to use in the Unity editor is just 720p resolution. So you can add a new option and then do 1280 by 720p as a fixed resolution. So I'm just going to select that. And then this can be the resolution, which I use for testing my game in the editor. So now we can hit play, and we can move around the screen very, very slowly, but it's there. And so if we want to kind of correct that a bit, let's click on the gatherer, and let's change the move speed. I'll set it to 12. Let's hit play again, and let's test that out. Actually, we can, if we want, we can even change the move speed value in the editor while it's playing. So I'll just take this value and set it to 20. And now we'll move around, and you should see our character moves faster. So it's a pretty handy way to just kind of play around with different settings and see what you like. So when I turn it back to 5, you can see it's much more sluggish for the character. So if we make the number 50 here, then you'll see that I can just make the character indefinitely walk, and there's very little or even no drag for the character. So he's not really going to stop. It's almost like the character is just standing on ice for right now, which isn't really what we want. So that's something you need to play around with the linear drag. When you increase this, it's going to add a stopping force for the character moving. And if you increase the move speed, then obviously the character is going to be moving with more force. And let's rename that variable to be move force as well, to be more specific. So the values that I was finding work pretty well in the demo that we're kind of rebuilding here is 100 for the move force and 25 for the linear drag. So let's hit play, and kind of test that out and see how that will work for our character moving around the screen. So what I would do here is hit play and change both the move speed and the linear drag until you get values that you actually like. So if we put something like 4 for the linear drag and, I don't know, 100 for the move speed, we can move our character around the screen, see how fast it stops, and see if that would make sense for our character. The character shouldn't have much sliding, so we do want a pretty strong linear drag, so I'm going to boost that up to 6 for now, and we probably want the character to walk a little faster on the screen, so I'm also going to boost the move speed. Let's do 150, and let's see if that's a little better. So walking fast enough now, but maybe not enough drag. So I'll try 10 for the linear drag. Stops very fast now, but not fast enough moving. So let's do 200 for the move speed. And these are values that are, at this point, kind of arbitrary. It's not really a physics-based game, so we just need the stopping and the moving to look kind of right. So we can just bump the move speed up more, 250. That's looking pretty good there. So we can go with the values of 250 and 10 for the linear drag and the move speed. So I'm going to put 250 here and click right here and do modified component, apply to prefab gatherer, and then 10 for the linear drag, apply to prefab gatherer. While we're ahead, I also want to rename move speed to be move force, since we're doing a force-based character. So let's rename that up here to be move force, and I'm going to set the default value to 250, since that's what we kind of decided on, and make sure we use the right property name down here for fix to update. Now if we go back to the Unity editor, we'll see move force here, and we have our linear drag. Just making sure that the character prefab still has the same values. You can click into that, but you can also just tell if it's using a custom value or the prefab value. If it's a custom value, then the field here will be kind of like bolded and white like that. But if you revert it to the prefab value, then it will just be grayed and not bolded. Okay, so at this point, we are getting the import directional movement for our character from the new Unity import system, and we're using that to move our character around the screen using a dynamic mode rigid body and applying a force to it, having our character be slowed down by linear drag. In the next few parts, we'll work on actually adding the animations in and having the character face the right direction depending on what the import direction is. So in this part, we're going to take our character, which can already technically move around the screen, and add 4 directional animations to it. So we want our character to be able to do all of its animations in up, left, right, and down motion. So we'll start with idle and walk, and later we'll add in swing animations as well. So before we get started with that, I want to do a couple things with our scene. First off, I want to grab the main camera and change the background color. So if you select main camera from your scene hierarchy and go to environment and the inspector, you'll have background type. If it's set to skybox, change that to solid color. And let's change the default background color to something nicer than that default blue. So I like to go with something like a dark gray as the default background. So the other thing I want to change is that when we enter play mode, you'll notice that it tries to reload and complete the domain. This is part of making it so that when you play the game in the editor, it should perform exactly like it would in an actual build of the game where you have it published and everything. But when we're working in the editor, generally speaking, we just need to kind of test and make sure that the code we wrote is working. So we can save some time entering play mode by enabling play mode options. To do that, we can go to Edit, Project Settings, go to the Editor tab, scroll down to the bottom, and we can enable play mode options. So there's Reload Domain and Reload Scene. Reload Domain is the part that takes the majority of the time. So a lot of times I'll just have Reload Scene enabled just cause. But you could have them both turned off if you want it to be as fast as possible. So with just Reload Domain turned off here, we can hit play, and you can see we enter play mode almost immediately, since it doesn't need to spend the time reloading the domain every time we hit play. Okay, now that those two things are out of the way, let's actually focus on the animation for our character. So if we go to the characters folder, we have the character here. And if you haven't already, you're going to want to add a animator component to the character. So I think I might have done that off screen, so I'll just remove that real quick. We double click into the gatherer prefab, go down to where we have add component, add the component animator, and that'll be inside here. So as I may have mentioned at the beginning of this series, the way that I'm going to be setting up animations is that we want to be able to attach a tool to the player and have the tools transform move around as our character animates. So if we did this the traditional Unity way of going into the animator window and setting up a bunch of blend trees in here, what would happen is that it would take the transform positions we set on each keyframe and try to blend them halfway in between as we're moving from, say, the walk right state to the walk down state, which means that the position of the tool isn't going to be set up correctly. So to get around that, we just skip blend states entirely. Now, there is a plugin online that is pretty good for handling this kind of thing. It's called Animancer, but I'm not going to use that in this project, simply because I don't want to force you guys to have to use an external plugin. And when I provide all of the code at the end as part of the patron itch.io package, I don't want to force you to have to, once again, download an entire plugin just for the simple setup we're going to be doing here. So instead, we'll just write our own code. It'll be relatively simple, and we just need to make sure that the player is facing the right direction depending on what our player input is that we're getting from the input system, from player input, as we did in the last video. So anyway, enough about that. We're going to be setting up a animator controller, but we're not going to create any links between all the animations. The animation switch and code will be done in our scripts. But in order to easily set up the clips on our character, I'm going to be creating a animator controller. So I'm going to right click, create animator controller. I'll call this AC Gatherer, and then we can click on the Gatherer prefab, go down to the bottom where we have runtime animator controller none, and drag in the Gatherer AC. So when you have that set up, you can click on the Gatherer character and go over to the animation window. And now you'll have the option here of creating animation clips. So you can find the animation window by going to Window, Animation, Animation here, and then just dock it in whichever part of the screen you want it to be in. And so we'll be needing to create our animation clips inside of the Gatherer folder. So I'm going to hit create clip, and let's go ahead and add in our animation. So I'll call this clip Gatherer idle right and hit save. So for the samples, I want to take this down to 5, which gives us 5 keyframes in a single setting to change and manipulate our character. We're only going to be actually setting a idle frame right here at the start. Okay, so to set up this Gatherer right animation, we just need to go into the Art Gatherer's Exterior Characters folder, and we're going to grab the walk right frame 0, and I'm just going to drag this in here for the character. I think it's not letting me because we have to have the character selected. Okay, so character selected in the hierarchy, drag the frame into the animation window and let go, and then Gatherer Sprite will be a property, and our frame of animation is right here. So you could hit play, and you could see that it will just keep looping through whatever frames we have set here, but there's only one, so it's just going to be the character kind of just standing there. So let's create idle up, down, and left as well. So I'll just create a new clip, and I'll call it Gatherer idle down. Let's find the down walk animation, expand it, and get the 0 frame, and just drag that in here. And also set the samples to 5, just for consistency. Make sure the important part that the sprite frame is set to frame 0 here, so 0 seconds, 0 frames. And we can go ahead and do this a couple more times. So Gatherer idle up, samples to 5, find the animation frame, expand it, drag it in here, and then we need Gatherer idle left. So Gatherer idle left, hit enter, 5 samples, and let's grab the animation frame and just drag that in there. Okay, so we'll work on the other animations a little bit later. Let's just start by getting the directions to work on our character. So if we go to our characters Gatherer folder where we have the prefab, you'll see these 4 animations. So what I want to do is combine these into a scriptable object where you can have up, down, left, right animation clips stored in one scriptable object. And the scriptable object would also be able to tell you what animation you should be playing based on directional input from the player. So this is going to mean we need to write a new script. So I'm going to go to the assets folder, and we're going to create a script folder, and I'm going to move the player controller script into here. So let's right click and do create folder scripts, and I'll drag player controller in here. So any new scripts are just going to go in the scripts folder. So, after the domain reloads, give it a second. So now entering the scripts folder, let's right click, create a new C# script, and I am going to call this directional animation set. I think that should work pretty good. And you'll see in the inspector that Unity will go ahead and default this to a mono behavior, but we're actually going to change that class type to a scriptable object. Let's go ahead and double click to open up the directional animation set. And then let's change the class it inherits to scriptable object. So a scriptable object is different from a mono behavior because a scriptable object, when you create an instance of it, it rests in your assets folder. They don't exist in the scene, which means they don't get removed from the scene. And you can use a scriptable object kind of like a mini database, something that you can reference for data wherever you need it across your game. So it's great for things like items where you want to know stuff like the item value or what the item name is, stuff that never really changes, but you might need in your actual game objects in your scene. So like a character that exists in your scene might have an instance of a item, but that doesn't mean that it needs to be constantly updating what that item is or the details inside of it. So for that kind of stuff, a scriptable object works really well. However, to create a scriptable object, you don't attach it like a mono behavior script. Instead, you would want to do create asset menu up here at the top. And generally with that, you want to specify a file name. So I will call this the same file name as the class name as default. So directional animation set, I'll just copy paste that in there. And then you want menu name, which is the path to find it when you right click and you go into the create menu. So we want, let's use the name of our project here, Gatherer top-down RPG, and then the final path to the exact link in the menu will just be the directional animation set. So when we're right-clicking, going into the menu, we're looking for Gatherer top-down RPG, and then directional animation set. When we click on that link in the menu, it's going to create an asset in the folder we're currently located in our project viewing window. So, things to know about scriptable object. First off, it doesn't have a start and update method. It's not an object that exists inside of your scene, so you can't use it like that. Okay, but what the scriptable objects are good for is storing data that is going to be consistent in your project. So for instance, that could be animation clips that you're using for your character. So we're going to create 4 properties here for the animation clips. So let's go ahead and add a automatic backing field to our property so we can set it in the inspector. So field, serialize field, and then we want a public animation clip. So that's what we were just creating, the idle up, left, right, down. And we want one for up, get private set so we can't change it from other scripts. And I'm just going to copy and paste this 4 times, or 3 more times rather, so that we can get the other directions. So we want one for down, we want one for right, and we want one for up, down, left, right. Okay, so we need left. The order here can be whatever you want it to be. Okay, so we can go ahead and create this scriptable object, and we'll add a little bit more code later so that our scriptable objects can tell us which clip we should be showing. But for right now, we can at least see it in the inspector. So let's go to Unity, and we want to have a place to store our scriptable objects. So I guess for us, since it's still tied to the character, let's jump into the Gatherer character, and we'll just put them in here for now. So I'll right-click, go to Create, and at the top here, we'll have our new menu, Gatherer Top-Down RPG, Directional Animation Set. So as you can see, this scriptable object has 4 fields that we can set, up, down, left, right, clip animations, and then we can use that wherever we reference the scriptable object, or the scriptable object can take that information and have its own functions as well. So instead of calling it directional animation set, I'll call it directional animation set underscore idle. Yeah, I guess just underscore idle. So let's assign down, left, right, and up to their fields here as we would expect. So gatherer up goes to up, down goes to down, left goes to left, and right goes to right. And you know what? I'm going to swap right and left here. Up, down, left, right sounds better than up, down, right, left to me. So I'm just going to go into the editor and let's just move the positions here. So they have the same naming and everything. So doing this shouldn't unset anything in the inspector, but it should change their positioning. So let's click on set idle, and now we can see up, down, left, right. So where are we going to use this animation set? Well, that would be in our player script. So let's go into scripts, player controller. And then up here at the top, let's add a field to set that animation set. So we'll have field, serialize field, public. Let's see, directional animation set, and that is going to be idle. Get private set, so that we can only change this in the inspector or inside of the script. And then we can go back out and click on gatherer. And then we can see the field for our animation set. So if we click on this little button over here, it'll look through our project for any directional animation set scriptable objects, and we can set the one that is relevant here. So I'm going to click here for that. And it does occur to me that other characters might have a idle directional animation set. So I'm going to go ahead, go back to the characters folder, and I'm going to rename this. I'll just call it gatherer idle. I think that's specific enough because it's clearly a scriptable object, not an animation clip. So it shouldn't be a problem naming wise. Okay, but now we have this set for our player controller. So our player controller knows what the idle clips are going to be, and we just need to have it set the right one. So to do that, we need to feed some kind of facing direction into the animation set that is our current set, and then we play the animation clip from that using the animator component. So since we need the animator component, we're going to need the animator. So let's get that, private animator underscore animator, and then we'll get that down here with animator equals get component animator, just making sure we have it referenced at start. We're also going to want to know what our current animation set is. So I'll just do a private directional animation set, current animation set, or we could just say current set. At the start, we'll just set this to idle. So let's do current set equals idle inside of start. And then whenever we're updating our character, we want to make sure that it's playing the correct animation. So we can have a update method. This doesn't need to be in fixed update because it's not physics, it's sprite animation based. So what we can do in update is try to get the correct current clip from the directional animation set. So I'm going to do underscore current set dot get, let's say, facing clip. And we need to tell it what direction we're facing. So for right now, I use axis input directly. And then this is going to give us a animation clip. And I could call this the expected clip, what we expect the animator to be playing. So let's create this function inside of the directional animation set. So I'm going to hit control period here, generate method, and let's go over to directional animation set. So this has been automatically created. I'm going to change internal to public. So the two things we're going to need to do here is to get the closest direction to the input. And I'm also going to rename this parameter. We're going to say facing, since we're not necessarily taking the raw input, but rather we're taking the direction that we expect to be facing and turning that into an animation clip. So we're going to get the closest direction to the input. And once we have that, we are going to return the animation clip based on closest direction. So to get the closest direction, we're going to want to create another function for that. It's going to return a vector2. I'll call it get closest direction. This is going to take a vector2. I'll call it input direction, I guess. Okay, so we might expect that it would generally be normalized before we return it, but we want to make sure that the direction doesn't have a magnitude associated with it, and based on its up, left, right, down directions, that we return it to a magnitude of 1 to normalize the vector. So let's do vector2 normalized direction is going to be input direction dot normalized. And how I'm going to do this is we're going to take the input direction and compare it to each of these 4 directions, up, down, left, right, represented as a vector2. Check the distance between the normalized direction and those directions, and whichever one has the least distance is going to be returned as the actual final facing direction. So we're going to need the vector2 closest direction. So this is going to store so far what has been the closest direction, and I guess we can default that to vector2 0 by default since we haven't compared it to anything. So we're going to need to start with having the closest direction so far. And then we can have a float for the closest distance as something we just cache once, and then we check if the new distance for the thing we're comparing to is less than or greater than the last one. So that can also just be there. Next up, I want an array of vectors that we're going to check. So up, left, right, down is the contents of that array. So we need a new vector2 array with 4 positions, and I'll call this directions to check. And this will be a new vector2 array with a size of 4. And now let's create the contents, and that is going to be vector2.up, vector2.down, vector2.left, and vector2.right. If you needed to do, let's say, 8 directions or something, you could always have more directions to check, and then you could account for stuff like up left and up right. But we're just doing 4 directional animations for our game here, so that's all we need. Okay, so right here at that point, we don't need the 4 there. The 4 goes here when we actually initialize that array. Okay, so now we need to loop through all the directions and just figure out which one is the closest. So let's do a for loop. Int I equals 0, so I is index, and then I is less than directions to check dot length, and I auto increments with ++ every time we go through this for loop. So for the first one, we want to automatically assign it to be the closest one because we haven't checked anything yet. So I'll just have a quick boolean here. First set, bool first set is equal to false. So if first set is not true, so got to put the exclamation point there at the start there. So if the first set is not set to true, then we're just going to take this and make it the first one. So closest direction equals directions to check I. And then we just need to get the distance between the input direction and, in this case, it will be vector up, but it could be whichever one you check first. So the one we're checking. So to do that, it's pretty straightforward. Let's set the closest distance to vector2.distance, and then we just put in 2 vectors. So let's see, we want input direction, and then we want, as the second vector, directions to check I. Okay, so that's how we get the first one set. It's going to happen automatically. Don't need to do any extra checks. Otherwise, we compare to the current closest direction and distance. Okay, so the rest is pretty straightforward. We just check the distance between the input direction and each of the other directions to check. So let's get a new float in here. So I'll call it next distance, and this is going to be equal to vector2.distance between input direction and directions to check I. And remember, every time we go through this loop, I is auto incrementing. So the second time is going to be down, and then it'll just check left, and then it'll check right. Okay, now that we have the distance, we just need to check if the next distance is less than the closest distance. So if that's true, then closest distance equals next distance. So if it gets in here, then we have a closer vector found. And if that's the case, then we also want to set the closest direction to be equal to the one we're currently checking. So that's directions to check I. And I guess we're getting a little error here, use of unassigned variable. So I suppose we'll have to initialize the closest distance with 0f as a value. As long as we have this first set check, that shouldn't be a problem, since in here we're going to set the real values for those to be compared. Oh, also something I forgot, got to make sure that first set gets set to true after this one. So first set equals true. If we forget to do that, then it's always going to be just going in here and automatically setting whatever here as the closest distance without doing a real check. Okay, so we have the closest direction set if it is actually closer than the last one. And we also set the closest distance, so that's all good. Now we just need to exit this for loop when we're all done and return the closest direction. Okay, and that is giving us a error as well. Has to unassigned local variable. Okay, so I guess we'll initialize this to vector2.0. Should only really be a problem if we fail to come in here to this bit, but that's why we're having this boolean check. So that should be fine. Okay, so we return the closest direction after everything is found. And with that closest direction as a cardinal direction, up, down, left, right, we can come back up here to the getFacingClip function, and we'll use that direction to determine whether we show up, down, left, right as the animation clip. So vector2, and this is going to be closest direction equals get closest direction based on the facing direction. Okay, and then let's just do like a switch statement here. I think you can do a switch statement like this. We'll find out. So a switch on the closest direction. So we're checking what the closest direction is, and then we'll have different cases. So because vector2, up, down, left, right are predefined vectors, I think this should work, but we'll see. So in the case that it is vector2.down, we'll do something. Let's see if we get a error message. So you can't use the switch statements on vectors like that, I forgot. So instead we'll do a if-else statement. Okay, so if the closest direction is equal to not vector2.0, but vector2.left, then we'll do something. Else if, and don't forget the else, that's important. We'll check if it's vector2.right, then we'll do something else if, let's see, closest direction equals vector2.up. Okay, then we're going to do something. And then lastly, else if closest direction equals vector2.down is what we're missing here. Then we'll do something. And I also want to just put in one more else at the end as like a error issue, which is that the expected value is none of what we actually thought we would get there. So we can throw some kind of error message. You could either use debug log error, which will just automatically log something to the console, or you could throw it as an exception. So something like throw new argument exception. Then as the message, we could say something like $, quotations, direction not expected. And the reason for the $, is so that you can do this, squiggly brackets, and then closest direction as a value, and end the parentheses. So basically, this part will just take the actual values and automatically insert it into the string. So you don't need to concatenate your strings together to form a final one. You can just kind of include the values as part of the string. Pretty handy. Okay, anyway, let's actually figure out what we're going to do based on left, right, up, down. So this should be pretty obvious. We're going to return the clip based on if it's left, right, up, or down. So let's return, let's see, left. And then for right, we'll return right. For up, we're going to return up. And for down, we will return down. Okay, so what we've effectively kind of done here is created the logic for a blend tree without having to blend the properties and the animator clip together as we move between our directions of left, right, up, or down. Instead, it's just going to be returning the animation clip exactly as we keyframe it, and then we just do animator.play to play that clip directly. No actual blending between the animations whatsoever, which is what we want for our purposes. So I'll just kind of put this up here for another second for you guys. This is probably the most complicated code we're going to write for this series. So let's go ahead and add a summary. Okay, so get closest direction based on a normalized input direction. Return the vector2 direction in the list of directions to check that is closest to the input direction by comparing the distance between the input and all direction vector2s in the list. Hopefully that makes sense. Okay, so this one up here, and by the way, if you want to know how to like quickly add these in Visual Studio, if you just do 3 forward slashes, it'll automatically fill part of this in so that you can just describe what a function actually does and how it works. But for the getFacingClip, after comparing the expected facing direction to the direction options, return the animation clip that most closely matches the input facing direction. Hopefully that's pretty straightforward for you guys. After we get the closest direction, we just use that to pick the animation clip. And if for some reason none of these actually match a valid clip, then we'll have a argument exception. Okay, so now that all that hard work is done, we can go to the player controller and let's see, in update, we're going to get the facing clip and we're going to set that to the expected clip. So I think what we can do here is just check that the current clip isn't already the facing clip, because if it is, that doesn't make much sense to tell it to play again. So what we'll do is that whenever we set a clip, we'll have a private animation clip, current clip here as well. So if, let's say, current clip is null, or current clip does not equal the expected clip, then we're going to tell the animator to play the expected clip. So animator, and I think I made that underscore animator as a private class variable, and we'll do equals, oh sorry, animator.play expected clip. We do need to give it a dot name here though. So let's see, animation clip has a name, and that's the animation we're going to play. Okay, so one little gotcha of doing animator play like this is that the state, the animation state inside of the animator has to have the same name as the clip. So if we go back to Unity now and we check animator, you'll see that there are these 4, you could think of them like animation states. So right now they all have the same names as our animation. When we tell it to play one of these, it's going to be playing the states automatically here. So instead of doing right-click make transition to these states as you normally would with a standard blend tree, our logic is actually just inside of our player controller script now. So just something to be aware of if you're trying to play a clip and it doesn't exist in here in your animator controller, then you could run into a bit of an issue there. But this should work basically fine in general. So this is one of the things that the Animancer plugin was kind of trying to fix, I think, making it so that you're not reliant at all on having an animator controller. But for our purposes, it should be plenty okay like this. So let's see, we have the idle animation. Actually, let's just go ahead and hit play. It might already work. Let's hit play. Okay, up, down, left, right. Okay, so it's kind of working. If we put down, then we face down, right faces right, left faces left, and up faces, yeah. Okay, so I know exactly what's going on here. It's that when the input is 0, we're still setting the input, and then it's automatically picking out our direction based on that. So let's hit play there. Let's go into the player controller script, and where we have on move, we want to have a facing direction that is separate from our axis input. So we only want to set the facing direction when the player is doing something like pressing a directional key that should actually change the direction the character is facing. So this will be a separate variable from the raw axis input. So we'll do underscore facing, you could just call it underscore facing or facing dir for direction. I think that's good. And we can set that to axis input, but we only want that to be the case if axis input does not equal, let's say, vector2.0. Then we can set the facing direction in here. Just got to make sure we make the private field, so generate the field up there at the top. And then when we are getting the facing clip, instead of using the axis input, let's use the facing direction. And that should fix our problem. So let's go to Unity, and we'll go ahead and hit play. Let's hit play. Up, down, left, right. Okay, as you can see, it's working great. So let's also hit play and play. Our default facing direction is, I guess, whatever's at the top of the list here. So if you want it to face down by default, then you can make that the first direction to check. So let's go into the script editor, directional animation set, and let's just swap the positions in this directions to check. So whatever's first is going to be the one that most closely matches vector 2.0, since it would all be in equal direction from here. So all we need to do to make it face down by default is do vector 2.down and then check vector 2.up. And then that should work just fine. So let's go back to Unity, click inside of here, hit play, and there you go. The character faces down by default because that's the first one to check in our script. And we can do left, right, up, down, and we have all of those animations. Okay, so now that we can switch animations using our directional animation set logic, we just want to add extra animations for walk and then animations for the swing animations. So this should be more straightforward since we already have the hard logic created. Let's exit play mode, and I'm going to create new animation clips for our gatherer character. So I'm going to go to the animation window, click on gatherer in our hierarchy, click on the drop down for animations, and let's create a new clip. So this is going to be gatherer walk right, I guess. It's fine to start like that. So for samples, I'll put 10. This is more relevant now because we're actually going to have multiple frames of animation. So how I like to do it is basically I'll just have one keyframe for each point in time I want to change the character's animation. So if I want to have 10 frames per second, then samples of 10 can make sense there if you would intentionally be changing it 10 times per second. It doesn't necessarily have to be like that, though. You can add more samples if you want. So with the art, I'm going to go to Gatherer's Exterior Characters, and let's grab all 4 of the Gatherer Walk Right frames. So you can hold Shift down, and then you can select them all. So left click, hold Shift, click on the 3, and you'll get all 4 of the ones selected in between them. Then just drag them up here to the animated window. And because we have 10 samples, they're going to be at those 100 millisecond intervals by default. So if I hit play, you can see we have our walk animation. Now that might actually be kind of fast for this character, so I can change this to 5, and you'll see that it slows down correspondingly. One way to make it slower, but not the only way, of course. And that's the more of the appropriate walk speed. So if we go to Assets, Characters Gatherer, we want to find that animation, click on it, go to the inspector, make sure that looping is turned on. Walking should be a looping animation. Later, when you have the swing animations, you'll definitely want looping to be turned off. So to make things a little bit quicker, I'll just click on Gatherer Walk Right, Control C to copy, and then deselect it, Control V to paste, and I'll do that 3 times. So we'll take Gatherer Walk Right, and we'll do Gatherer Walk Left, and then we need to find the animation frame. So in the art pack, go to the characters folder, and then we have the walk left frames. So I'll select all of these, drag them into the window up here. You might need to select the gatherer in the hierarchy, and then select the gatherer walk left. Oh, hold on. For some reason, that's showing the idle animation. So when you do things this way, it's not added to the animator. That's why it won't show up here. So we have to click on animator. Sorry about this. And then you go to Characters Gatherer, and we want to drag in these new animations. But first, you should name them properly, or else it won't change to the proper animation later. So let's change this to Gatherer Walk Up, and then click here, Gatherer Walk Down. And now we can add in left, up, and down to the list of animations that exist for our character. Kind of like that. Organize and snap it how you wish. As long as it's clearly identifiable, it should be easy. I'll actually kind of try to match them here. So 3 columns for 3 different animation sets. And we can match up to up, down to down, right to right. That looks pretty good. Okay, now when you click on Gatherer and you click on the menu, you'll see those new animations pop up. So we want Gatherer Walk Left, and then we get the frames from the art pack. Walk left 0 to walk left 3. Select them all, drag them in there, and make sure that the first one snaps to the 0 second, 0 frame position. If you want to test it, go to Scene View and hit play, and you can see that animation. So just do the same thing for, let's see, walk down and then walk up. So select the 4 frames, drag them in here, hit play to test. Okay, now let's change to walk up. Select the 4 frames, drag them in here, hit play. And yep, that's pretty much it for the walk animations. So we can also do the swing animations at the same time here. So let's create a new clip, and I'll call this Gatherer Swing Down for the first one. We'll set the samples to 5 at least for now. That might change later. And we need to get those swing animations. So Gatherer Swing Down as a sprite sheet. I'll select all the frames, drag them in here, hit play to test, and there's our swing down animation. So we can also create the new clips inside of the animation window. So this will automatically add them to the animated window. So this might actually be preferable as a way to do things. So Gatherer Swing Right, set the samples to 5, grab the 3 frames of animation, and drag them in here. And then we want to create a new clip, Gatherer Swing Up. Samples to 5, grab the frames of animation, drag them in here, hit play to test, and we'll do it one more time for Gatherer Swing Left. So Gatherer Swing Left. Once again, we grab the frames of animation, drag them in here, change samples to 5, make sure they're at the 0, 0, 0, 1, and 0, 2 frame positions, you can hit play to test and just make sure it's swinging properly. So if we check the animator, we should see all of the animations here. Feel free to line them up nicely if that helps you out. But generally, we're not really going to be doing much in this animator window because, once again, the logic is actually just determined through code. This is just kind of like placeholders where we change the clip. Okay, so now let's take a look at our character. In the inspector, we can see that we only have one spot for the directional animation set of idle. So we need to add the other animation states to the player controller script. So if we go into player controller, let's go up here to the top. I'm just going to copy paste this, the whole field serialize public animation set idle. And we're just going to change this one to walk. And then we're going to change it to swing. Okay, if we go back to Unity, we should see those fields in the inspector. So I can't remember if I actually created them. Let's do walk. We have not yet. Okay, so in the characters prefab folder, let's duplicate the gatherer idle, or you can right click and do create gatherer top-down RPG and just create a new one. I'll just Control V, paste it in, and let's do walk here, and then Control C, Control V, paste it in, and we're going to do swing. So because the names are pretty consistent with the animation clips, it makes it pretty easy to find where those animations are in the list here. So just once again, swing down goes to down, and so on and so forth. So swing up goes at the top here, swing left goes to left, swing right goes to right, and that set of animations is now set up. So let's do gather a walk. Same thing, down to down, left to left, right to right, and up to up here. And now, if we click on our character and the hierarchy, so once again, editing the prefab so it changes everywhere, then we can set our animation sets here. So set the walk, set the swing, and our character now has the animations. So the last thing we need to do for those animations to play properly is just add a little more logic to our player controller. So for our player controller to go along with these different animations, we want to have some kind of logic, which can help us determine whether we should be switching to idle, walk, or swing animations. And then the character should also be behaving differently during those different animations. So for instance, during the swing animation, maybe we make it so the player can't move, and we lock out other animations from being able to be switched to. So we can do that by creating a script that manages a state, maybe has a few different settings like can move during the state or not, and then we change the state in the player controller script and assign the animation correspondingly. So how I'll set this up is that we'll change it so that we have a dictionary that takes a state and assigns it to specific animations for each character, rather than setting the animation set on the state directly. And then that'll mean that different characters can share the same state without sharing the same animation frames. So let's create a new script to manage our states. So I'll create a new C# script, and I think we could just call it character state, I suppose. I'll double click into here, and let's have a scriptable object. Remove this stuff. For right now, I'll just put in the field serialized field, and this will be a public boolean can move get set, and a state by default I think should be set to true here. So we'll just make that the default value. Okay, so it's a mostly empty scriptable object, but this will be useful for us. So let's go back out to Unity, and we need to create an asset menu for this as well. So create asset menu, file name, character state, and then menu name is going to be equal to, let's see, gather top-down RPG / character state. Okay, and now we can create some states. So let's go back out to our project. In the characters folder, I think I'll just create a new folder inside of here, and I'll call this states. And then we'll double click in here, right click, create, gather top-down RPG character state. So I want to call these something that's kind of corresponding with the animation to be played. So I'll call this first one state idle. Let's copy paste it, and I'll call this state walk, and Control V state, let's see, swing or attack, or whatever you want to call it. Or maybe this should be state use, since that's what we're calling the action. So maybe that's what the state should be called too. Okay, So with the use state, I want to turn off can move. So for idle and walk, we'll be able to move, but for the use state, we will not be able to. The other thing I want to put in the character state, let's see, should be whether it can switch out while an animation is being played. So field serialize field, public bool, can exit while playing. Let's do get set, and this will default to true as well. But let's go back out here, and for use, I want to turn that off. So this will mean that until the animation finishes playing, we can't exit a use state. But for state walk and state idle, we can move and we can switch to other states while the animations are playing. So now back on our gatherer, let's go to the player controller, edit this. But it might look a little weird for right now, but I'm actually going to change these into character states. So character state idle, character state walk, and character state swing, which means we're going to get a problem with setting our current state to the idle animation here. So what we want to do is take these character states and assign the animation based on what state we're actually in. And in order to have that key value pair reference, dictionaries are a good way to do that, but dictionaries aren't serialized inside of Unity by default. So there's a good plugin we can use and just download and bring straight into our project called Unity Serializable Dictionary. It's MIT license, so it's free for you to use across any project. And this will allow us to assign a key to a value in the inspector. So the key is going to be the state, and the value is going to be the animation set that we want to play. So let's go ahead and grab this. I'm just going to download the zip, and I'm going to bring it into our project. So let's create a folder for it. In scripts, I'll just right-click, create folder. I'll call it plugins. And then from 7-zip or whatever tool you're using, we can just extract this straight into there. So now with Unity Serializable Dictionary, we can use the code inside of that in order to do what we need. So inside of here, I'm going to make another serialized field for our dictionary. And let's call it a public serializable dictionary. Let's see, what's the class we want? Yeah, serializable dictionary of a type. And the type is the key and the value. So the key is character state, and the value is going to be animation clip. So I can call this property, let's say state animations, and then get private set. Okay. And if we go to Unity now, what you're going to see in the inspector, after it compiles, let's make sure there's no errors. So let's go to Window Console, pull this over here. Okay. So it's because this error is still there. So I'm going to comment that out for a second, just so we can get things to compile. And as you can see, idle, walk, and swing now expect a character state. And there's the state animations dictionary down here with nothing in it. You can expand it, and there's a plus button to add entries, which we want to do. And you can see you can take a character state and an animation clip. So first we have to set up the character states. So select idle, and then we'll select walk. And for swing, I'm going to select use. We're going to change that to be the use state in our script as well. So for state animations, take idle. So state idle, whenever we're playing state idle, we want to assign the animation set here. So not animation clip, but actually the directional animation set should be the value. So let's go back into the script and just change a couple things real quick. So animation clip is actually directional animation set, because we're doing 4 directional animations, not just 1 animation per state. And then for swing, I'm going to rename this to use. So if we go back out, okay, then now we can set the use state to be use as the state. And then state animations, we want the directional animation set of idle. Add a new entry, and then we'll choose use, which is going to be assigned with the swing animations. We'll just rename that to be gather use, possibly. And then for state walk, we want to use the gatherer walk animations. If you want, then go to the characters gatherer, and you can rename the gatherer swing set to gatherer use to be gatherer use, if that makes more sense for the game. Okay. basically, I think we kind of have it set up here. So we have the state scriptable objects set up. We have the state animations linked up, and we just need to use all of that in the code. In our code, we're no longer going to be setting the current set, but the current state. So let's change this to be character state here as well. And when we start the script, we're going to be setting it to idle still, but we're talking about the character state idle, not the animations idle. And we also need to rename this. So current state, Control V, copy paste, fix that. So before, in order to get the correct facing clip, all we needed to do was access the directional animation set that's currently set up there. But now we're going through a character state in order to get that directional animation set. So we need to access the dictionary to get the set, and then from the set, we get the facing clip depending on the facing direction. So we could create a function in order to get the correct animation clip based on the facing direction and the state we pass in. So let's create that function, and it will be private animation clip, and we could call the function something like get state facing clip. And we could call the function something like get facing clip from state. We can rename that later to something a little more elegant. And this is going to need the character state we want to check for the animation set. So character state, and then we want the vector2 facing direction. And then let's come inside of here. So the first thing we're going to need to do is to get the directional animation set from the dictionary. So from the dictionary, we want to try using the key to get the value. And if it actually finds the value of the directional animation set, then we can get the clip from it. Otherwise, we're going to probably return an error. So let's start by checking if it actually has the value inside of it. So state animations as the property dot try get value, and we're going to use the character state as the key to get the value, and then we out this to a directional animation set, which is going to be animation set. Okay, so this function returns a Boolean. So if that is true, then we can come in here for the valid case of being able to actually get the final animation clip. Otherwise, we can debug log error and say, I'll add the $sign there in case we need some kind of variable name or something here. And we'll say character state and squiggly for character state dot name is not valid in the state animations dictionary. And actually, instead of saying not valid, I should say is not found in the state animations dictionary. So in this case, that basically just means we haven't set up a key that corresponds to a value in state animations, so it fails to get the value of the animation set. Hopefully that makes sense. But if we do find that animation set, then we can return the facing direction. So we'll return animation set dot get facing clip with the facing direction, and that should be all we need there. Of course, if we don't do this, then we need to return null because it failed to return anything. Failed to find animation set and animation clip corresponding to the character state. Now, the reason I made their parameter for character state here is we may, for some reason, want to check for a clip that isn't the current state. So by having an option up here, you can check any state, even if it's not the current state. Okay, so, and now, anytime we want those clips, we just need to call this function. So instead of doing current set get facing clip, we'll just do here, get facing clip from state, and I will put in underscore current state, and the facing direction is underscore facing direction. So let's go back to Unity and hit play and just make sure everything still works. So if we hit play and we go up, down, left, right, a lot is happening behind the scenes. So we have these states, and we're assigning this state to our character. In this case, the only state we have actually being used yet is the idle state. And based on checking the dictionary for our idle state, we can get the directional animation set that corresponds with that state for our character. And then we just get the facing direction like we did before. So this whole dictionary's point is just so that you can reuse states across different characters, but each of those characters can have their own animation set up for that state. So in that way, you just have a lot more reusability across the different characters in your game, and you don't have to keep creating a idle state scriptable object for every single character that's unique to each character, because generally those characters are going to have the same kind of setup here. Being able to move, can exit while playing, but you could of course create an alternative idle state if you wanted, just with create, gathers top down character state. And then that should work just fine for you. You can just have a different idle state for different characters if they do need to idle somehow in a different way. Okay, so lastly, it occurs to me that, this get facing clip from state part is something that really ties in pretty directly with the state animations dictionary here. So what we can do, and this will be to further make things more reusable and kind of separate our code a little bit, is to take this function out and this type of scriptable or serializable dictionary and create a new class from them, where if we need this function in a different character script, we can get the same thing going on. So let's create a new C# script for this. In C#, in the scripts part of our project, I'm going to right click, add a new item, C# script, and I will call this, what should we call this kind of dictionary? Character state animation dictionary? Character state animation set dictionary. Does that make sense? Maybe just state animation set dictionary is good enough. Okay, and then as a .cs file, let's add that to our project. Okay, so in player controller, we're going to grab this part over here to this, and we're going to make it so that this class extends from this. So this state animation set dictionary is just a instance of a serializable dictionary that has this as the key and this is the value. So let's take the class and make it public. I will remove the namespace for now, though we may come back to that later. And then we want to add the function inside of here. So in player controller, I'm going to grab all of this bit right here, cut it out. Let's go to this dictionary class and I'll paste it in. So the only thing we need to do here is to get rid of this bit, state animations. The dictionary is the class object itself, so when we do try get value, we're already targeting this state animation set dictionary. And now let's go to player controller, and instead of a serializable dictionary of this type, we'll just paste the new class name in, and then state animations we can do for expected clip state animations dot get facing clip from state. Okay, let's see. Any errors here? Inaccessible due to protection level. Okay, so that's an easy fix. Just go back to the class and we'll make this function public. And now it can be used from other classes. So in player controller, we can do state animations.get facing clip from state. So this cleans up our player controller script quite a lot. And it also makes it so that we can reuse that function we wrote for any character that wants to use a state animation set dictionary. If we go back to Unity and we look at our player controller script, you'll notice that the dictionary has mysteriously vanished. So how we get it back is that we add at the top right above state animation set dictionary, serializable as a tag here. So with that, jumping into the Unity editor, we should see the state animations dictionary pops up here one more time. We do have to re-add in the references since technically the type of object has changed. So this is a new object we're setting fields in. So none character state, we just change that to idle, directional set idle. You know the drill, just add it in for all of them. Use gets use, and then add one more in. Walk is going to get walk, and then we can hit play. And it's working just like before, except now we just pulled the logic out to its own class, and once again just making our code a little bit better. So that's it for this video. In the next one, we're going to add in the logic for switching to the walk state. I promise it gets easier from here now that we've done all of the groundwork for these states. Okay, so in the last parts, we got movement kind of working. We can move between up, down, left, right animations. But as far as changing the state out goes for our character, we're still kind of locked in the idle state. So we just need to add in some extra logic to our player controller script so that we can switch to the walk state and the use states. So let's go ahead and add that in. It's going to be in the player controller script. So first off, inside of the update function, I want to have logic for if we're going to switch between the idle state and the walk state. So above changing the clip out, let's check if the current velocity on the rigid body, so rb.velocity.magnitude, because we don't care about the direction, is above some kind of walk velocity threshold. And if that's the case, then we'll set the current state to walk. Otherwise, we're going to set the current state to idle. Okay, so let's generate this property up at the top. And we'll also give this property a field so that we can change the value in the inspector. So field, serialize field, and we'll give it a default value of something very small like 0.05f. So since our game is running at 100 pixels per unit on the grid, I believe that 0.05 would mean 5 pixels per second of time, something like that. So moving pretty slow in order to be able to be considered idling. Anything below this is idling, and anything above it is walking, if we have no other interruption states, like using the tool as an action. So with just that, we can go back out to Unity, hit play, start walking around, and we can see that when we have velocity, we're actually using the walking state. Now, there might be cases where the character gets hit by an external force, so we're not actually pressing down on the keys to make the character walk, but the velocity of the character would be greater than 0, since external forces would be acting on it. So we could add in another condition if we want, which could be just checking if the axis input is not equal to 0. So if we do axis input does not equal vector2 dot 0, then we can walk. And I think we actually want that to be an and condition. So we want to make sure that it's not 0 and that the speed of the character is somewhere above the walk threshold. So in this case, we'll only be walking if the player actually presses keys to walk and the character is moving at some kind of speed above 0. So that can fix that potential future little hiccup. So right now, it's working pretty good. And you can tweak the settings if you need to. So like in the inspector for player controller, you can change the walk velocity threshold if you want that to be a little bit lower or higher. But for right now, it's working good. Okay, so the more complicated bit is going to be the use action and any other kind of interrupt actions. So first off, if we're in a state which should not be able to switch back out to walk or idle automatically at any given time, then we're going to want to make sure that that doesn't happen. So for all this, we want to check first off that the current state dot can exit while playing is set to true before we just randomly switch between walk and idle states. And then if it is a state that can't exit while playing, then we want to check if the state is finished. So we can do that by having a float variable that will check the time till the end of the animation clip. So time to end animation is should be less than or equal to 0. And only in those conditions can we switch between walk and idle animations. Okay, the other thing is that we're not going to be wanting to change the animation clip as well automatically if it's in one of those special states that locks the animation in place. So I'm going to extract all this out to a change clip function or method. So I'm going to right click on it with it selected and do quick refactoring, extract methods, and let's call it change clip. And then this change clip bit, I'm going to pull right inside of here so that on a random update, we can only change the animation if we're in one of these states that can automatically change directions or change animations to different states. So that means we'll be calling change clip when we use the tool that is in our character's hands. So down here on use, we want to change the state to something new. And then when we change the state, we also want to change the animation. So because generally when we enter a new state, we also want to change the animation, we can set that into a property with a setter, and then that setter can change the animation for us rather than needing to call it down here in every different action call. All we need to do is change the state and have that state change the animation. So closer to the top, let's make a property for that. Public, and this is going to be character state, current state, capital on the C. So this is a property, not a field, but we're going to use the private field that we already set up down here for our get and set functions. So get is going to return the current state, the private field, and then set is going to change the current state to the new value. but I only want that to occur if we're not already in that state. So if the current state is not equal to the new value, then we're going to change the current state. And if we change the current state, then we also want to change the animation. So we'll do change clip. So we change the animation clip whenever we change the state. And then inside of here, we can set the value for our timer. So we'll do time to end animation is going to be equal to the new clip time. So we could actually get the animation clip that we set the current clip to be inside of here. And then after we change the clip entering the new state, we want to get the time to end the animation. And we'll set that to the current clip dot length. So the time of the new animation we just changed into. And I'll add the underscore down there, and let's make that a private float variable. Okay, and this will just default to 0f before we set it. So to have this timer work, we just need to decrease the time to end animation on each update. So we'll do time to end animation minus equals time.delta time, and we could like clamp this to 0 so that we can't have a negative number. That might make a little bit more sense. It's not necessary because we're already checking if it's less than or equal to 0. So just to make it make a little more sense, let's remove the minus equals, and then we'll set it equal to mathf.max, the higher of these two values of the time to end animation minus the delta time, so the updated time, or 0. So the lowest it can be now is 0, which makes a little more sense because if the animation has already reached the end of its playing, then there should be 0 time left, not necessarily negative time. So that can just be a little timer function, and we reset it whenever we change states. And that means that if it's a can exit while playing, we don't need the timer to be done. But if the state can't exit until it's done playing, then we wait for the timer to be done before we can change back to a default state like walk or idle. And there are other ways you can do the same thing, but that's probably the most straightforward without like getting into coroutines and stuff like that. So now all we need to do, I believe, is to actually change the state when on use occurs. So we're going to change the current state here, and I'm accessing the property to make sure the setter function gets called to the new state, which is the use state. And any other time I use current state, I also want to make sure I'm using the property, not the field. Otherwise, the setter function with change clip and time to end animation doesn't get called. So whenever we have current state, we just need to change that to the property name, current state, capital on the C, no underscore. And that way, changing the state is going to make sure that we actually have all that code run as well. Okay, and then back up here, the last thing I want to do is make sure that we can only set the state from within our player controller, since it's the brain controlling everything. So I'm going to make it a private set function, and that should basically be good. So hopefully this works. Let's go out to gather top down, hit F, and okay, we have a null reference. So let's check this right here. Change clip did not set the current clip. So let's take a look at change clip. Okay, so yeah, we do have the expected clip being set here, but we're not necessarily changing what the current clip is set as a value. So we could either return the animation clip from here and not even have a current clip variable, or we can set the current clip variable. So if we are changing it right here, then I guess we can set current clip equals to expected clip. Otherwise, the current clip is already set, so we don't need to change it. Okay, let's go back out, hit play. Okay, and now that's working. So we can still walk up, down, left, right. Let's try left mouse button click to see if we can get the swing animation to occur. It does, and you can see that after the timer is up, we've returned to our default states of idling. Okay, so here's one little thing, which is that while our character is using the tool, it can still move. So, you know, some games you might have that kind of thing. But in this case, I want the character to stop completely when we use the tool. So we need a logic check inside of here to make sure it's in a state which can move. So let's see. In fixed update, we'll just look at the current state. So if current state dot can move, it's a property we set up for every state, then we're going to allow it to move. Otherwise, we can't. So as long as we mark a state as not being able to move, then it won't be able to move while in that state. So if I hit play now, and then we use the left mouse button click to go into the use animation, you can see the character stops moving. There might still be a little bit of movement there because the linear drag isn't strong enough to stop the character completely. So if you want the character to stop almost completely as soon as we change into the state, you could increase the linear drag on the character just so that it slides around less. So in here, rigid body 2D, linear drag, you can set that there. Now, if you want to be able to use the tools with another key rather than just having to left mouse button press on keyboard and mouse, then we can go into the controls for player input, actions, and then click on input action asset. Double click into there, find the use action, and we can just add a new binding here. So I'm going to add a binding, and in the path, I'm going to change that to listen for a key that we want to use, and I'll just press F here to find the F keyboard key, assign that, and then we'll put this in control scheme keyboard and mouse. And now while you're using keyboard and mouse, you can use the use action by pressing F on the keyboard as well as left mouse button down. And if you wanted, you could actually remove the left mouse button as an option for triggering that use action. But let's go into play mode after saving this, of course. Hit F and then hit play, press the F key, and we can see that that's working. Now also note here, because we put in the check that we can't enter a state that we're already in, that if I press F a bunch of times, it won't actually enter the use state until the use state is already done and we're back in idle or walk, simply because we have that restriction. So only entering a state that we're not already in, so we don't reset the timer, we don't change the animation clip. So that's pretty much it on getting the basic state machine of our controller to work. We'll have to, of course, set up the tools, add it to the character's hand, give it some box gliders, and allow it to actually interact with the game world, which we haven't set up yet. So we're probably going to be working on the tile set very soon. So now that our character's basic movements and states are set up in a suitable fashion, we can actually go ahead and build out a game level for our character to actually use, rather than just having this black background. One last thing before that, though. I want to go into Characters, Gatherer, and the swing animations. I may have mentioned at one point that they shouldn't loop. Now, technically, because our animation switches out after the timer is up, we don't see this as a problem, but we should have the swing animations turned off for looping. So just select each of them in the inspector and disable that, just so that in the future, if there was ever a case that for some reason the animation wouldn't switch, it shouldn't just keep looping the animation. That would be pretty weird from one button press. So now we can go ahead and go to Window, and we want 2D, Tile Palette, and I'm going to dock this over here in the top right, and we can start creating a tile palette from the art we bring into our project. So for this to work, you'll need some kind of Pixar-based tile set palette. I'm, of course, once again using Gatherer's Exterior, and the tile sets are located in the Tilesets folder here. So first, I'm going to start and just create a water palette. So I'm going to click here, create a new palette, and I'll call this water. For the cell size, I'm not sure if we need to manually set that or not. We'll try with automatic, and then it should adjust to the 16 by 16 size of our sprite frames. But let's see how that goes. Sort mode, we'll just leave as the default. Later, we'll change sorting in the project settings if we need to. And in the project, I'm going to just create the palettes inside of the Tilesets folder where the art was generated. So for Tilesets, I'm going to right click and let's do new folder. I'll just call this palettes. Go into it, hit select folder, and now we can see that the water tile palette has been created. Now there's nothing inside of here. We need to bring some tiles actually into this for it to work. So if I look at this water tile, I believe it's just a single tile there. Yep. So very basic water. And we can take the tile set water and just drag it into here. And so that we can see this better, I'm going to actually drag this down a bunch so that we can see that each of these grids is going to have one space for one tile. Now let's drag this into here as one single tile. And we need a folder for the tiles. So I guess I'll create a new folder here. Right click, create folder, tiles. And inside of here, I want a new folder for each tile palette's tiles because there's going to be a lot of tiles generated for a single tile palette generally. So I'm going to right click, new folder, water. So I'm going to store all of the water tiles in tiles and then water. So select into here, and then you can hit save to generate the new tile. And then we have one tile, which we can use for drawing on a tile map. Now, our scene doesn't have a tile map yet, so we can go to the hierarchy, right-click, do 2D option, tile map, rectangular. And then we'll have the tile map grid. So if I click down onto the grid or tile map, we can see that these tiles are pretty big. So this would be 100 pixels by 100 pixels. So in order to make the cell size actually fit our palette size, which is 16 by 16, we just shrink the cell size correspondingly. So 16 pixels when 100 pixels is one unit is going to be 0.16. So 0.16 for the X and 0.16 for the Y. And now this should look more like what we would expect. So this tile map, I'm going to rename it to be water. So we'll have different tile maps for different layers in our game. So some of those tile map layers are going to have tile map colliders so that it can block movement. And then others like water are not, at least initially. So all we need to do now is go to tile palette, and then we can select our tile, and we can start drawing on this water grid like so. Now, one thing you'll notice is that this actually puts the player behind the grid. So what we can do is if you click on the tile map water, you can change the sorting layer to be a different sorting layer, or you can change the order in layer to be something below. So generally, I think it's preferable to change the sorting layer, add in new layers, if you know that everything that sits on a layer should be organized below another layer, rather than trying to change the order in layer, which for things that are on the same layer, you can manually adjust whether they show in front or behind. So we know that water is always going to be beneath everything. So let's change the sorting layer, add sorting layer. And then here we have a plus to add a new sorting layer. Give it a name, and I'll call it water, of course. I'll pull this above default. And if we click on water, the tile map, and change the sorting layer to water, now the water is always going to show behind the default layer, which the player is currently sitting on. Okay, so now we can go back to the tile palette and continue working on our grid. Now, you can keep left click holding and dragging around, adding in one tile at a time like this, but a faster way is just going to be to switch to the box fill tool. You can press U on the keyboard or click up here in the tile palette to do so. And I'm just going to drag a gigantic grid, almost a limitless amount of space for our character to walk around and interact with. Of course, the limitation is going to be the land that the player stands on, not the water. So in order to add some land in, let's create a new tile palette. So I'll create a new palette, and I am going to call this one grass. So this is just corresponding with the art pack that I have and the files inside of it. You can organize your tile palettes by whatever name you want. So I'll just create here, and let's go into art, gatherers exterior, the Tilesets, palettes, where we had it saved before, and I'm going to select the folder to save the new tile palette inside of. So if I click on the palettes folder, you can see now we have the grass tile set asset file. And to fill that, we need to grab some of the sprite sheets and pull those in here. So let's see, I can't remember if these are actually separated yet by already or not. So I'm going to click on Tileset Grass, Sprite Editor, and yeah, it looks like we still have to adjust it. So the sprite mode for a tile set like this needs to be set to multiple so we can slice it. Let's go into Sprite Editor, Apply. I'm going to slice this based on cell size 16 by 16, since that's the grid size for this tile set, and I'll hit Apply. And now we can go to the tile palette. And now, if we pull in the image, it's going to be using all of these different frames to generate the tiles. So let's drag this in here and drop it. And then we go to Tilesets, Tiles, create a new folder for the grass tiles. Double click into here, select folder, and we'll generate the 20 or so tiles. And now we can draw these onto a tile map. Now the ground is going to be on a different layer than the water. So under grid, okay, and if you get this pop-up, hit save. So for the grid, I want to right-click on it, 2D option, 2D object, tile map, rectangular, and I'll call this one the ground layer, since the ground might have grass or other types of terrain on it, but it's all going to be part of the same organized layer. So to draw ground, we want to go under the tile palette and make sure we're drawing on the ground layer right here, using the grass tile set. And let's drag in some tiles. So we can use the box fill tool for the basic grass tile here. So I'll just box fill tool, drag something like that. Once again, we can see that the ground is on top of the player. So we need to go to the inspector and add in a new sorting layer. So I will call this the ground sorting layer, and I'll move this above default since the ground is beneath the player and anything else that's standing on the ground. So the sorting layer for the tile map renderer, sorting layer, ground. Okay, that fixes that problem. So now we also need to add in these edge tiles, indicating that we're kind of like on the border between the water and the grass or something else. So let's grab those edge tiles with the normal paintbrush, be on the keyboard if you want, and draw in the tiles where they belong. So we're drawing edges here. So wherever there's an edge that borders something else, just draw that in. Now, I'm not going to put these bottom tiles on the ground tile per se, because in this case, I want the collider shape to be just the ground. This part right here is supposed to be where the ground meets the water, and the player is not supposed to be able to walk on it. So it shouldn't be part of the same tile map collider, which will make more sense in a minute. So I'm going to actually create a third layer. So let's right click on the grid, go to 2D object, tile map, rectangular, and I'll call this something like ground 2 for now, I suppose. So we'll have another layer, and with the same tile map, I'm just going to draw on ground 2 now, and let's draw in these tiles below here. So if we click on ground, you can see the orange shape that goes around it. If you click on ground 2, you can see the orange shape that goes around it. So that's roughly where the tile map collider shape is going to be. So in the inspector for ground, the normal ground, I do want to have a tile map collider. So let's add a component, tile map collider. Okay, and when we add the tile map collider 2D, you can see that there's a bunch of these little tile map shapes. Now, in this case, each of these would be blocking the player, which is not what we want. Instead, we need to use a composite collider so that the only the edges around here are going to block the player from entering or exiting this space. So add another component, and we want a composite collider 2D. It adds a rigid body, so change that to static because the ground is not going to move in this game. That would be really weird. So to take the tile map collider and add it to the composite collider, just check used by composite. And when you do that, all of these lines in between should lighten up, and the composite collider is going to basically combine this shape into one single collider, which is going to create edges around our ground where we can't walk across. So now if our player was to get to the edges over here, then it would actually block the player from being able to walk there. So to show that even with the tile map collider in composite mode, we can still walk, let's hit play, and you can see we can still walk around this space. So it's only the edges that are blocking us. But we really can't see the edge here because we have no follow camera to actually track the player around the screen. So let's add in the Cinema Machine package so that we can actually follow the player. So in Window, Package Manager, let's go to, in this dropdown, Unity Registry. And we want the Cinema Machine package here. So type in Cinema Machine, and we're going to install this to our project. So Cinema Machine makes it really easy to add a follow camera to our scene and track the player. Okay, so with Cinema Machine, if we right click in our hierarchy, we're going to get access to the Cinema Machine menu. And I think what we want is either 2D camera or a virtual camera. Let's try 2D camera first. And this, when we add it, is going to create this game object virtual camera. If you look at the main camera now, there's also a new component automatically added in here called the Cinema Machine Brain, which controls the Cinema Machine. So let's click on virtual camera, and I'm going to try using follow, and I'm going to follow the gatherer. So let's hit play and see if that kind of works here. Okay, it does. So that's really all we need to do to get like a simple follow camera. And now you'll notice that as we get to the edge of this ground, we can't walk over it. We can't walk onto the water. Since this part of the ground is not on the ground layer, but ground 2, we also can't walk onto that. So the edge of our ground is serving as a proper barrier, preventing us from going off the edge onto the water, which is exactly what we want. So lastly, for this video, there's also in the tiles some decor. And we can add the decor to this tile palette as well. So we can draw onto a decor layer that rests above the ground. Doesn't block the player, but just serves to make the grass a little bit more interesting. So let's go to the inspector. I'm going to click on the decor tileset file. We're going to change it to multiple, sprite editor, apply, and I'm going to slice this up. I know everything in here is 16 by 16, so I'm going to slice it, apply, and now those frames I can bring into the tile palette. Even though this is one image and the decor grass is another image, we can put them on the same tile palette, kind of like this, just dragging and dropping. And I'm going to put the new tiles into tiles grass, select folder, generates the tiles, and now we have more stuff to draw onto a tile map. So I'm going to save the changes. On the grid, I'm going to right click 2D object, tile map, rectangular, and I'm going to call this a doodad layer. And in the tile palette, I'm going to change to the doodad layer, and let's start drawing some stuff on it. So one thing you could do is change the brush down here to a random brush. And so with that, I'm going to click on the tiles I want to randomly select between. Let's add to random tiles, and I'll also select these as well. So that gives us 21 tiles. Uncheck pick and add to random. And now if we draw with the random brush, doodad layer, okay, we got to click away from there so that we only select one square. And yeah, now it's going to be giving us random selections. So basically, in a nutshell, first you pick the random tiles. If you need to add more, check add to random tiles. Then uncheck both of these so that you're not setting the random tiles. Then click on brush mode with only one square selected up here. And then that's how you'll be able to easily draw like this onto the doodad layer and just kind of have a pretty random selection of tiles being added to your grid. So this is a little easier than like manually needing to place every single item. You could just switch back to default brush if you want to manually place exactly the ones you want on your area. You can still use the eraser tool and get rid of a few of the extra doodads if this becomes a bit overkill. Yeah, generally that kind of works there. So one thing that is a little bit of an issue here is that this flower is showing above our player. So we need to work on the sorting of the game so that sprites that are above another sprite show behind the sprite. So let's take a look here. The doodad layer is still at sorting layer default, order in layer 0, and that should be where the gatherer is as well. So that means that the sorting is going to be based on something else. So we're going to make that something else the Y position for the objects in our game. So to change that sorting and make sorting by Y, I think we need to go to edit and then let's see, project settings. It might be graphics, universal render pipeline. Double click on that. And then was it renderer 2D? Yeah, okay. So universal render pipeline from graphics, and then you double click into renderer 2D. And then transparency sorting mode, we want to make custom access, and that access should be Y. So the way you do this is a little bit different in the basic built-in renderer. So if you're not using URP as your renderer, the settings are going to look a little different, but you're still going to be looking for that kind of sorting mode and then changing that to custom access sorting by Y. The other thing you got to change for this is for the tile map renderer, change the mode from chunk to individual. So this will mean that whenever we place a different object here, that the sorting is going to be based on that individual object, not on, I guess, like the average of everything inside of that grid, which would be kind of weird. So let's hit play. And now we can go behind the flower and in front of the flower, and the sorting is going to change kind of based on that. Now, you'll see that the sorting is kind of based more on the center point of the character. We already set up the pivot point at the start of this project. So the reason that's happening is because we need to go to the gatherer and change the sort point from center to pivot. So let's enter the gatherer prefab, change sprite sort mode to pivot, hit play. You can see that the character is going to be sorting much more close to down here than it was before, where it would have been around the head area. So this makes a lot more sense. It might still need a little bit of tweaking. For instance, it still seems like the flower itself is sorting based on a center pivot point. So it's basically this pivot point of the character versus the pivot point of the flower. But this is a lot more close to what we were looking for. So let me go ahead and see if we just take those flowers, if we can actually just sort based on a pivot point at the bottom of its frame rather than the center point of its sprite frame. So I'm going to go into Tilesets, Decor Grass. Let's open the sprite editor and let's move these pivot points down to more like right around there. And I could just copy and paste the values for them. So y will be 0.1 and the x will be 0.5. Let's do that for each of them. 0.5, 0.1. Then we can go to the next one. Custom 0.5, 0.1. And then this one, 0.5, 0.1. Okay, let's hit apply and let's test with that flower. So I'll go back, hit play, apply, and let's see. Okay, nice. That's a lot more like what we would expect. So now both the sorting point of the players down here and the sorting point of the flowers right there. So going in front or behind of the flower is exactly what we would expect, basically on where both of those two things touch the ground. And that's going to look a lot more appropriate as we kind of develop our game. So you'll have to do that for each of the sprites. It's a little bit tedious, but I think it's definitely worth doing to make the game look right. Okay, so for this one, the sort point should be more like that. So 0.25, can copy that value, go to the next one, 0.25, next one, 0.25, next one, 0.25. Another thing you could do if you're going to be making your own sprites is just making it so that when you create a sprite frame, that the center point is always where the sorting point would be, and then you don't need to manually change it. But then that means you're going to be making your sprites bigger, which would be, you know, a little bit weird too. Now you might also want a second doodad layer for stuff like this where it's so close to the ground that it would always be showing under the player. So you could have a sortable doodad layer, and then you can have another doodad layer where there is no sorting for stuff that's close to the ground, unlike a flower. Alternatively, you can make the flowers game objects by themselves and have different rules for them, just sorting them like other game objects, like the player has its own sorting pivot point setup. But generally, that's the gist of how all of this is going to work. So for right now, we could just hit play, kind of hit save, go around testing it. So we can walk behind this rock. Might not make sense, might make sense. Kind of up to you on how you're going to make it work in the game. So in this case, I'll actually take these objects and I'll put them on a non-sortable layer that's just always beneath the player. So I'll take doodad and I'll copy it to a new layer, and I'll just call this beneath player. So now let's disable the first doodad layer, and then for the beneath player doodads, let's erase everything that doesn't belong here. So that would be the flowers. So erase, make sure you're erasing on beneath player, and let's get rid of that. The flower, 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 yep. Just going around here, and any of the flowers don't belong there. And then all of this stuff will just always be beneath the player. Then we can disable this tile map layer, go back to doodad, enable that, and remove anything that doesn't belong here, which is everything but the flowers. So we can erase. Okay, and we want to erase doodad here. So erase everything that's not a flower. And you can Control Z if you need to. And then enable the beneath player layer. And then when you need to draw a flower, just draw it onto the flower layer. So let's paint with brush, doodad, and I'm going to add this to the sortable layer for these. I'll also change the brush from random to default. So we're just selecting the exact frames. And let's add those in, just a few more flowers where we need them. Okay, so now finally, just to make sure that doodad beneath player is always going to be actually beneath the player. Let's add in one more sorting layer, add sorting layer. And then we'll give it a name. And I'll just call this beneath, I guess. Because it's not always going to be doodads, but yeah, I guess that works for now. And then doodad beneath player will actually make that on the sorting layer beneath. I'll reorganize it in terms of what's sorting on top of what here. So doodad will be on top of the normal doodad. Then we hit play, and we'll see that these rocks are always beneath the player. These little weeds are always beneath the player. But the flowers still have sorting based on the player's position. So that's the basics of setting up your tile map with different layers, adding in tile map colliders, and getting your objects to sort properly, depending on if you want them to be beneath the player or actually sorting based on the Y position. Okay, in this video, let's add a little walk particle system to the player where when our player is walking in one direction, the particles will be emitted, kind of walking behind the player, indicating something of kicking up dust as the player runs around the screen to make things just a little more interesting. So in the gatherer game object, I'm going to jump into the prefab. And let's actually do that from the project window so that we get the blue background. So gatherer, under characters, let's jump into gatherer prefab. And inside of here, let's add in the hierarchy a new game object. So I'm going to right click and do create empty. And then this I will call run particles. So for this game object, we need to have a particle system. So add component particle system. And a lot of crazy things are probably going to happen right now. So first off, we don't want the particles to be pink. I'm actually going to stop the particle system for a second because that's kind of blinding. And we need to go down to renderer so that we can set a material that we're actually going to be emitting for the particles. So inside of gatherer's exterior, I have a tiny little particle that I'm using for this. And this is basically just some very, very simple pixel art. And we can turn that into a material like exists right here by right-clicking on the PNG of the particle we want to create a material for, going to create material, and then we can call this something like material pixel particle, as I've already automatically done up there. And then we can change this to, let's say, particles, standard unlit, and then you just need to drag the particle into this map here, the albedo map. And then we can use this material in our particle emission. So if you click on Run Particles, go down to the bottom here and just drag in that material to here. If we hit play, then now you can see that the particles are emitting something that's not just pink missing material. However, we can't really see any of the shape of the particle. So let's click on the material particle. And instead of opaque for the rendering mode, you want cutout. Okay, now if we click on particles and play, then you'll see the actual shape of the particles that we're trying to emit. Now those are way bigger than the player. So I'm going to take the size and I'm going to make it a lot smaller. So let's try, okay, one is 1 unit, which is 100 pixels. So let's try to make it something like 0.04 units for 4 pixels as its size. Okay, so we can still see they sort of have the shape still, which is good, but they're at a size which is more appropriate for our character. The velocity is also way too much, so let's play around with the settings a little bit. I'm going to take the start speed, and I'm going to make that more like 0.2. Okay, so now our particles are much smaller. Also, they're emitting in random directions and automatically emitting. So the automatic emission is fine for right now, but to change that to be based on when the character's walking, we would want the rate over time to be 0 and the rate over distance to be set to something else. Basically, how many particles do you want per unit of distance in that case? So for right now, we'll leave the rate over time active just so we can see what we're doing. But we're going to need to change some things. So first off, the lifetime of the particle, I want that to be much less. I'll make that 0.5 seconds. And then you'll see a lot of the particles just kind of disappear from the screen since they're fading away much faster now. And we also want them to be emitted from here, not in this random circle. So we can go to shape and change the shape of where the particles are emitted. I'm going to change the shape to a circle, and then I'm going to shrink the radius of the circle a lot. So this will basically put it right on top of where the character is walking at any given time. So it could even be something like a 0.04 radius, which means it'll be an 8 pixel diameter circle. And I think that works okay. The only thing now is that we want to make sure that the speed is in the right direction. So for that, I think you need inherit velocity to inherit the velocity of the parent. So I want the velocity to actually be a negative value. So I'll take the initial velocity of the parent when the particle is emitted, and I'm going to put it at negative 0.25. So we're going to be reversing the direction and slowing it by a factor of 4. I can't tell that right now because the speed is basically being determined by that automatic speed. So if you want the base speed to be eliminated, then just change the start speed to 0. And now all the velocity is going to be dependent on whatever the character's speed is when the particles are emitted. So right now it's just generating particles. The character's not moving, so it makes sense that they're not having their own velocity. So to change that, once we're done with all those steps, we just change the rate of emission to 0 for over time. And then for distance, we can say something like, I think it's per unit of game space. So I'm going to put 50, which means 50 particles per 1 unit. That seems kind of high. Let's try 10 to start. And let's go back out to the main scene. If we expand our gatherer, we can see that the run particle system is there. Let's hit play and see what we get. So if I hit play, we can see the particles get emitted when I run. So if I stop running, there's no particles. But they're not moving very much. So maybe we need to increase the values on the run particle system. So I can just click run particles here while the game's running, and we can change the values and just test things. So let's do inherit velocity, and I'll do -1 instead of -0.25. And so the particles are actually moving with the player right now. So another setting you got to change is simulation space to world. So this will mean that the particles are going to have their own basically movement and transform. They don't move with the parent. They are, in a sense, kind of like their own objects. So the particles aren't their own game object, but they do have a space within the world. So that's going to help us fix that there. So if you exit out of play mode, note that the settings go back to what they were before. So let's jump into the prefab and make simulation space world. Inherit velocity, we can leave that maybe -0.5. And emission, I think 10 was working good. So let's hit play and test that again. Okay, that's looking good. You'll notice that because we have the negative velocity multiplier, that the particles go in the opposite direction from where we are. So this is already working pretty good. Things we could change would be fading the particles out as time goes on. That's an option. I think it already looks pretty good as it is right now. But if you want that kind of thing, then we can go to run particles in the prefab outside of play mode, of course. And let's change the color over lifetime. So if we go in here, you can click on this gradient editor. And right now it's going from pure white to pure white with full alpha. So if you click at the top notches, those are going to control the alpha, the transparency, and the bottom one is going to control the actual color. So if you click on the top one, turn the alpha down to 0 or something like that, which means it's going to fade out over time. We can hit play and test that. And you'll see that they kind of appear to fade much quicker now, since those parts would be transparent. So if you want it to be more of a rapid fade rather than fading over time, you can add a third notch and just pull this in over here, set it to 255. So between these 2 points of the lifespan, it's going to be completely visible. And then it's going to very quickly drop to 0 alpha now. So if we hit play, it's going to look a little different here. You can see that there's a little bit more time where the particles are visible before they fade out. But they do last for such a small period of time that you only see them for a few frames of animation too. I think I can see the transparency fading on like the last frame where they're visible. But it's still kind of a subtle difference there. So that's basically setting up the walk particles for our character. And that's going to be it for this video. So in this video, let's add a tool to our character's hand, add a collider to that tool, and make it so that if the collider comes in contact with a harvestable object, that it will do something with that object. In this case, we'll start by destroying it, but later on we'll set it up so that we can actually harvest resources from the harvestable object. So let's start off by editing our gatherer character. Now, a tool object is something I'm going to want to actually put on a child game object. The tool is going to somewhat be independent of the main gatherer character, but we still want it to track its position around on the screen. So as a child game object, it'll inherit the position, but we can have it have its own set of colliders and add extra scripts to it and so on and so forth. So I'm going to, in the prefab of our gatherer, add in a new game object. So I'll create a new empty object and I will just call this tool for right now. Now, in order to show a tool or a sprite, let's add in a sprite renderer. And then let's find a tool from our project that we want to use. So you can basically use any sprite you want, but in this case, I have these single frame sprites like a copper axe, which we can just drag and drop in here. So I'm going to add this as the sprite. So when we add the sprite here, you can see that it's not really in the right position. So I'm going to take the tool object and I'm going to move it up to the player's hand. Now you'll see that because we're sorting the player based on its pivot, which is somewhere down here, that it's going to put the tool behind the player. So this is something we can work with in the animator and make it so that depending on if the character's facing up, right, left, down, we'll set the sorting in layer as a custom forced sort for the tool to show above or behind the player. For right now, we'll just have it set there behind. And we want to give a collision shape to this axe head. So let's add a component. And I am going to be looking for, I would say, a box collider maybe. So let's do box collider 2D, edit the collider shape, and stretch the sides to be roughly the size of the head. It doesn't need to be completely precise. It just needs to kind of make sense. And maybe we put it more on the right side of things, since this is the part which is going to be hitting a tree, and this part is not. So whatever makes sense to you, as long as this collision shape comes in contact with the collision shape of the tree or whatever we're trying to harvest, it should work later on. The other thing we got to change is making sure that it's set to is trigger mode, because we're going to be having kind of an event happen when this object hits another object. Because this collider isn't going to be used for physics, it's only going to trigger something to happen on the other game object. So we want it to be a trigger. We don't want it to be a physics collider. So let's finish up with that trigger shape. And then we can go back out to game mode, and we can see that we have the tool there under our gatherer character. So right now the tool isn't going to be doing anything. In order for this to do something, we need to create a new script. So let's jump into the prefab on the tool game object. So I'm going to add a component here, and we can give this new script a name. To keep it simple, we could just call it tool and do new script and create an add. So in the project, we're going to have this tool CS script, and let's get rid of the start and update methods. What we actually need here is going to be on trigger enter 2D. So when our tool comes in collider contact with a harvestable object, then we want to do something to that harvestable object. We'll start just by destroying the harvestable object, but later it'll be the harvesting mechanics. So first off, we need to check if the other object is a harvestable object or has a component called harvestable on it. For that to work, we need to create a new game object that has that script, the harvestable component. So let's go back out to the main scene, and I am going to grab an object from the pack. Maybe we go into grass here, and I'll just drag a pine tree onto the scene. So let's just drag that in there, let go. And maybe we just drag a pine tree into the scene. So I'm going to drag this into the hierarchy. And we see we got a new game object called tree pine here. I'll position it kind of where I want it to be. Or actually, no, I'll just leave it at 0, 0 for right now. And let's start by creating a prefab for it. So in the project, I'll right click, create folder, and let's call this an objects folder. And here I'll create a harvestable folder. So just keeping things organized. So harvestable, so it's a type of harvestable object. Jump into harvestable, drag the pine tree into here. And now let's double click on tree pine. So for this object, we already have the sprite renderer that was added automatically when we dragged a sprite into the scene. We want to, of course, change the sprite sort point to pivot. So if I haven't set it up already, that'll be down here at the base of the tree. And let's add a component, and I'm going to call this harvestable. So make sure it's spelled harvestable, and then create an add, the new script. Move these scripts from the base folder into the scripts folder. So that's harvestable and tool. And now I want to go ahead and take the harvestable script. And now I just want to open up the harvestable script and make sure it is being recognized properly. We're not going to need an update or start method, so I'll just delete that. And really, harvestable just needs to serve as a tag for right now. So that's all the script we need. As long as it's attached to the tree pine, we can check that it has the component harvestable and do something to the tree. Now we can see that the tree's down here. Let's position it a little bit differently. Oh, of course, right now the tree can't collide with anything because there's no collider. So let's open up the prefab, add a component, and I'll call this a circle collider. So the collider, right now it's the full shape of the tree, but we just want it at the base because we're going to swing the axe at the base of the tree. So let's lower the radius down and then offset the position to somewhere like there and maybe a little bit on X. So negative 0.1, negative 0.01 X seems to position it pretty good. Maybe even 0, just like the center point there. Let me zoom in. I guess the right amount is half a pixel. So negative 0.005, and that positions it right in the center there of the tree. Okay, now with this collider, we don't want it to be a trigger collider. This is an actual object in the scene. And, you know, given that that's the case, maybe we need it to be a lower radius. So 0.05, 0.04. Okay, That seems good for this. Maybe it'll be a little hard for it to harvest with the axe initially, but we can always change this later. Oh, and lastly, the tree is also going to be a physics object in the game. So let's add a rigid body 2D, put it in static mode because the tree isn't going to move, but it should block the player. Now if we go out, let's hit play and just make sure that it's working kind of as intended. And if we walk up to the tree, we can see that the tree is blocking us from walking over it, but only at the base of the tree. So we've got to get the sorting working at the top. You can see the sorting point of the tree is right here, but it should be down there. So we can just edit the tree sprite real quickly. So let's double click on tree pine and open up the image, go to sprite editor, and we need to change the pivot point from center to custom and move it down here to the base of the tree, probably right around there. Hit apply. Okay, that will offset the tree's position in our scene a little bit. So really it would have been better if we did that first, because you see that when you move the pivot point, it moves the sprite, and now the collision thing is down there. So we'll have to edit the prefab a little bit, change the offset. I'll remove the Y offset, and then that puts it right on top of the pivot point. And let's remove the X offset as well. Yeah, that seems good for the collision shape there. Okay, let's go back out, hit play, test the tree. So we collide with the base, and if we go behind the tree, then we are actually physically behind the tree. So sorting's working better now, so that's cool. Now the last thing we need to do is actually make it so that this tool can chop the tree by having a collision occur here. So let's jump into the gatherer. We go to the tool, let's edit the tool script, and we want to check if we come into contact with a tree or a harvestable object. So for right now, let's get the harvestable equals collision.getComponent harvestable. And if harvestable does not equal null, if the object we collided with is an actual harvestable object, then we'll tell the harvestable object to get harvested. So we'll do harvestable.harvest. And inside of here, we could give it like a damage value or something later on. But for right now, we'll just leave that alone. Let's generate the harvest method inside of harvestable. So control period and then generate the function. Then we go in here. Going to make sure that this function is public so that it can be called from outside of here for any class. And then the harvestable object, we're just going to destroy the game object. So when the tree gets harvested, the object disappears, which is really as basic as we can make it for right now, but it gives us a good starting point to test. So let's hit play. I'll walk around, the axe will hit the tree, and then the tree is gone. Of course, if we duplicate the tree now a few times in the main scene, like so, then we can run around and get rid of those trees. So that tree's gone, this tree's gone, and so on and so forth. So at least at a basic level, we can recognize that the trees are harvestable objects, and we have a tool which can interact with them. So that's going to be the stopping point for this video. So in this next part, we're going to be focused on taking the tools and getting them to animate along with the character. So before we take care of that, though, one thing I want to show you is in the main camera, the grid snapping, I think it actually looks better with none for the pixel snapping. So if I show play mode right now and I move around the screen, you'll kind of notice that there's like a little bit of jitteriness as it tries to pixel snap, especially after an animation completes, like when I go back to idle state there. But if we take grid snapping and turn that off, then you'll notice with no grid snapping that the animations and the movement of the camera becomes much more smooth. So I'm actually thinking none is the way to go for grid snapping for this game. Okay, so next, in order to animate the axe or hammer, whichever tools, we need to have a pivot point set for them, which works well for our character's pivot point. So getting the exact number can be a little bit tricky, but the idea is that we want the axe to sort where when it's in the right hand down right about here, that it's going to show in front of the player. But then when the right hand is behind the character, a few pixels up when the character would be facing left direction, then we want it to sort behind the player. So I was finding if we go to the tool PNGs, that the value we want for the pivot shape is going to be, well, first let's go to pivot custom, and then we can move it. So right about here where the hilt is, but then down here to negative 0.15, I think is what I had for the value. So negative 0.15, in terms of rotating around a pivot point, that might not be the perfect spot for it, but that doesn't really matter because we're doing frame by frame animation anyway, so we can still adjust the transform to get the axe in the perfect spot. So let's hit apply here. So 0.125 and 0.15 for the pivot point. And I'm gonna also apply those same values to all of these other tools for right now. So select the other ones and then change the pivot point to custom. So that was 0.15 negative on the Y and then 0.125 on the X. So hit apply and let's jump into the gatherer prefab now so we can test this. Go to tool and then adjust the tool's position to be in the right hand right about here. Okay, and if it's not sorting behind, you got to change the sprite sort mode to pivot. So let's do that. And yeah, now we can get the sorting we're looking for. So right here is about where this sprite is going to sort into the back of the player. And when it's down here, it's going to show in front. So with that, we can animate behind and in front of the player, depending on which animation we're trying to do. So that's kind of what we're looking for there. So you'll notice that this also messes our box collider shape up, and a square box collider doesn't exactly match this blade shape that well. So we can change the box collider 2D into a polygon collider to kind of have a better shape. So let's remove that, add a component, polygon collider 2D. And under points, I'm going to delete all except for 4 so that we can have a simple shape here. So just delete the extra elements until you have just element 1, 2, 3, and 0. So let's delete those, then hit edit collider and drag the points to be roughly the shape of the head of the tool. So this will just make it make more sense when it's actually colliding with something on the screen, that it should kind of more closely match the shape of the tool. Okay, so now that we have that done, let's go back out, enter animation mode, select gatherer, and let's test first by doing, I guess, like one of the harder animations first by going to gatherer idle right, and let's do gatherer walk left, I suppose. So when we want to set the keyframe points for the tool, we can just enable recording mode here, then click on the tool, and we need to adjust its position on the screen for each frame of animation. So for this left animation, the hand is actually behind the player. So let's move this upwards and into a position which it should be when the gatherer is facing left. Then let's hit E to go into rotation mode and rotate it a little bit. Do a 180 on the Y value. So you could just set that here in the animation window. You can hit W to go back into move mode and then just move the axe roughly where you think that the hand should be holding it in the background. And we can reset the Z rotation as well if we want to, or we can hit E to rotate it and then, well, make sure you're rotating the tool, not the player. So click on the tool and then you can rotate this down if you'd rather it be a little bit further down. So the main thing we're trying to achieve with that sorting point is just that when it's here, it's behind the player, and when it's down here, it is in front of the player. So honestly, that can be one of the trickiest parts of trying to animate multiple objects together and having them sort correctly. But once we got it down, it will work pretty well. So let's jump to the next frame, and we can approximate where the hand is supposed to be here as well. So click on the tool. In this case, the left hand is swinging forward, so the right hand is swinging backwards. So let's move that backwards a bit. We can hit E to go to rotation mode and then rotate the axe down a bit if we want. Wouldn't rotate too much though, because we're just doing a walk cycle. And you got to keyframe it if you haven't already. So if you didn't turn on recording mode, then hit keyframe so that it remembers your position, and we'll add the position rotation values to the animation window. So let's go to the next one. So for frame 02, it's the same as 01. So I'm just going to copy the position rotation values into here. And let's jump now to the final frame. Hit W to go to tool move mode, and then move the axe forwards because the hand should be coming forward a bit as well. And we can hit E for rotation mode if we want to set the value there as well. Now, if we play this animation, we're going to notice that the animation is smooth, which goes completely against how our pixel art character looks. So how we can fix that is by changing the tangents on both the position and the rotation. So select all of the keyframes except for gather sprite, right click on them and do both tangents constant. Now if we go to the first frame, hit play, then we'll get that choppier pixel art look for our animation. And if we go to play now, we can walk with our axe in hand, and it's animated in the position that we want it to be. So, so you can test it and then just add your position rotation values for each of the frames if you need to. And basically we're just repeating those steps, but for all of the animations and frames. So it's going to take a little while. The next one I want to test though is going to be gatherer swing left. So let's go to that animation, make sure that you kind of scrub around here so that it shows the first frame. Move the axe into position. So select tool, enable recording, hit W to do move tool, move the X into its position, and then E for rotation mode. Okay, rotate it a little bit. In this case, we want to flip the direction of it because we're swinging to the left. And then we'll need to rotate the Z axis as well. So rotate this way back, kind of like so. W to move it into position. So in the second frame is when we're ready to swing, and then the third frame is the swing. So let's go to the second frame and set some new values. W for move mode. And let's rotate the axe even further back. Okay, like so. Make sure that record mode is on. Go to the final frame. W to move it. And then let's rotate it on Z axis, like so. Position it in the hand. Okay, and now we can test the animation. Hit play. So it's obviously smooth once again, but the keyframes are okay. So let's take the keyframes for position rotation, right click, both tangents constant, hit play. Okay, and then now we're going to have our actual axe swing animation. So you might think it doesn't look quite right, and I would probably agree that the X position on the first frame is not quite correct. So let's rotate this and move it kind of like so. Maybe it should be even behind the player a little bit. So let's hit play now and test. Okay, so now it takes 2 frames to kind of get the axe into position, and then 1 frame for a big swing forward. So this might look okay. Just kind of play around with it, get the settings you want, and repeat process for all the other animations. So let's do the walk right and the swing right animations. So at frame 0 here, we gotta hit recording. Let's select the tool, move it into position, rotate it. I'm going to rotate the Z forward a little bit so that the axe is kind of facing the ground a little more. I'm going to select these keyframes and do right click both tangents constant so that it will have that choppy pixel art animation look. Now let's go to the next frame, hit W to do move mode, move it into position, maybe rotate the Z a little bit. Okay, and then frame 2 is just like frame 1, so I'm going to copy the keyframes from frame 00 to 02, paste those in, go to the last one, move the axe back a bit, and then rotate it downwards. Okay, and try to make sure that the axe is showing in front, if we can. So if it's not quite working right, we can adjust the pivot a little bit more. The sooner you adjust the pivot, the less it's going to mess with your animations. But let's do negative 0.2, hit apply, and maybe that'll be a little bit better here for the sorting. So let's position that and test for all the animations. We might need to readjust the position now for these. And this is why I wanted to do the harder animations first, because those would have more problems typically. So just adjusting the position on each of them, mostly. Go to walk left, and same kind of deal. I'm going to rotate this axe down. Okay, and the axe is in the back. Okay, it's still filtered. It's still sorting to the back, which is what we want. So let's hit play and test that. It's overall still fine. And let's see, we did swing right, or swing left. Hit play. Okay, that's still looking fine. Maybe the positions need a little changing, but it's just a matter of tweaking it. And then here, it's fine that the axe actually shows in front because it would be in front for that hand, so that's correct actually. Okay, let's test the walk again. I just think that the axe is rotated too far down there, but aside from that, it's good. Let's move it up a bit. Okay, move it down on this frame. And then that's the 02, so I'm going to copy the values to 00, and just move it on this one. So since I just did this pivot point, let's copy it now to the other tools. Just going to select them all and then change the pivot to -0.2 so that we're consistent across all the tools. Okay, and now we have a few of the animations done. We can hit play, test our walk cycles. So when we're facing the left, our axe is behind us, and then when we're facing the right, our axe is in front. It does come way too far down there on that final frame, I think. So it's just a matter of coming in here and changing the position for that animation. Okay, and then there's the walk right edited a bit. Okay, so let's continue working on the animations. So let's do swing up next. So with swing up, remember the right hand is where we're holding the axe. So let's record the position changes and then E to go into rotate mode, rotate it into position. I'm going to flip the Y axis. Remember that the blade has to be facing where the character's actually looking for it to make any kind of sense. And let's rotate it and position it. Okay, and next frame, let's move it up here. So we're doing the swing animation, so this needs to move far back. That might be a little overkill, but we can test it for a second. And then final frame, we rotate the Z forwards a bunch, move the axe up here to where the hand is in front of the player. I'm gonna rotate the Z a little bit, and then just make sure that the box glider's kind of in here and that front middle part. That looks pretty okay. So let's hit play. And, well, we need that constant tangents for it to look right. So both tangents constant, hit play. And that's not bad there. But the charge up to the second frame is a little off. So maybe this is too much Z rotation. So let's make it more like 135. Then adjust its position. And then the first frame, 85 degrees on the Z rotation is probably okay. So let's hit play. Okay, that's looking better. So let's do swing down now. So swing down, enter record mode, select the tool, W to do move, move it into the right hand, which is now on the left here because we're facing down. Rotate it, and I think we're going to need 180 Y rotation so that the blade is facing the right direction. And just move it over here to the left. So on the second frame, we're going to have the full pullback. So rotate this and move it back. Here it's too rotated already, so we'll move it to something like this. And then on the third frame, we need to bring it down, rotate it a lot on the Z, and then position it in the hand. So let's get it to the right about there. Select all the keyframes, both tangents constant, and we can hit play to test it. So that looks pretty okay. I think maybe the pullback on the second frame is a little too much because we're supposed to be swinging down here, not overhead really. So let's rotate that a bit, move it into position. Remember to have recording mode enabled. And here, let's rotate it forward a little bit. Okay, maybe a bit more than that. Or who knows. And then hit play. Okay, maybe on the first frame, we do need it rotated more kind of horizontally like this. This is mostly just trial and error, so just get the positions to what you think looks good. It doesn't have to be exact. Okay, and then, let's see, gatherer swing left, we got that. We got gatherer swing right. Oh, no, we don't. Okay, so let's do that one next. Hit record mode, go to the tool. First frame, we need to position the axe out here in front. Rotate it, kind of like so. Maybe a little bit to the right. Then go to the next frame, move it further back, rotate it so that we have a big swing coming up. And then go to the third frame, move its position in front, rotate the Z a lot so that the axe hits the ground area, roughly speaking. And then we can select all of the keyframes, both tangents constant, hit play, and test it. So the first frame doesn't look right there. Let's rotate this forward a bit, I suppose, and then hit play. Okay, maybe on the first frame I want it to actually be more to the right. And let's put that there. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And then on the gather swing left, gonna have it like that. I suppose that'll do all right for now. You're free to tweak it later if you need to. Okay, so we have the important swing animations done. So those are looking right. When we have walk left, walk right. So up and down should be a little easier. Let's hit record mode, go to tool, move the axe into position, rotate it, and we're gonna 180 the Y so that once again the axe blade is facing the right direction. Select the tool, move it into position, kind of like so. And then next frame, you just need to kind of move it and rotate it slightly. And then next frame is the first one again. So I'm going to copy paste 0, 0 to 0, 2. And then let's animate the last frame. So moving it upwards in position again. And maybe rotate it a little bit out or in. Maybe doesn't really need that. So let's hit play. Kind of test it. We got to do right click, both tangents constant. Hit play. And that can be kind of our run animation. So I don't like the rotations as much. So let's kind of remove those actually. I'm just going to make it consistent 90 degrees for the Z on all of them. So you can copy paste the value into each frame, hit play, and you can just test it. So that looks better now that just the position's moving for that walk animation. So let's do gather a walk down now. Hit record. Let's see, select the tool, move it into position, which is on the left here now. And then we'll rotate. So got to rotate the Y 180 degrees, W to go to position mode, position it in the hand, copy and paste the values from this frame to the second frame, or 0, 2, actually it's the third frame. And then we need to manually set the values for 0, 1 and 0, 3. So let's move this kind of into the hand, and then 0, 3, we can maybe rotate that a little bit. And on 0, 1, I guess we'll try rotating it. I didn't like that for the walk up, but let's see how that goes. And of course, once again, we need right click both tangents constant. So let's test that now. I still think the rotation is a little bit much. So let's actually just have a consistent rotation of -15 degrees. And we can put that for all of the Z rotations for that tool. Okay, now let's hit play. Test it one more time, and that's looking all right. Okay, so we did all the swing animations, I believe. The easy ones are actually just going to be the idles, because those are single frames, so we can do this really quickly. So record mode, tool, position it where you want it, rotate the Z-axis a little bit down for gatherer idle right, so that it's facing the ground, not really like in front of where it's looking. So let's do gatherer idle up now. Oh, and make sure that it's showing the right frame, so you might need to scrub it up here at the top a bit. Into record mode, position it, so find the right hand, and let's rotate it, and 180 on the Y. So that means we're going to need to rotate the Z a lot more. And let's move this into position, maybe take the Z rotation and tame that back down to 90, and position it in the hand. Okay, that looks fine. Gather idle left, record. And let's do tool. So position it where the right hand is, which is in back this time. Okay, so we're going to need to rotate 180 degrees on the Y. Reposition it right about there. Maybe a little up. Okay, that looks good. And finally, gather idle down. Hit record. Go select the tool. Move it into the position. Rotate it. And 180 on the Y. Yeah, we need that for it to look right. So select the tool again, W to do move it into the hand, and set something for the Z rotation. So 0 is a little too little, so let's do -20, and that can be all right. Okay, so now just to test all the animations all in one go, let's hit play, do WASD, moving around. Okay, and when you walk, just check all the animations, make sure that it's still got that constant tangents, so we have that pixel art choppy animation look. And walk in all directions. We also want to chop in all directions. So hit F, F down, F left, F going up. And I think the way I set it up, the animations look pretty decent this time around. So hopefully with a little work, you can get it to look pretty similar. Once again, though, one of the main things that can be kind of annoying is tweaking the pivot value. So if you're using the same sprites as I am, 0.125 and -0.2 on the Y, seems to be working pretty good for me right now. So that's what I'll go with for this character. Oh, and one last thing, for the polygon collider we created, make sure you set it back to is trigger mode so that you can still run into trees and have it damage the trees like so when we collide into them. And then we'll work on actually making harvesting the trees work in the future videos. And then in the future parts, we're going to make it so that we harvest the trees rather than just immediately destroying them when our collider destroys them. So for the collider, you make sure you actually set it on the prefab to is trigger mode. If you do it during the game playing, it's not going to actually update when you exit play mode. So that's it for this video on doing the animations. That's probably one of the harder parts. So in this part, we're going to take the trees and turn them into an object that can be harvested properly. Rather than just a simple collision destroying the tree outright, we're going to want to be dealing damage to the tree whenever the axe or other proper tool collides with our harvestable objects. So in order to create that, I'm going to right click in the sample scene and create a new game object. So I will call this Harvestable Object, and we'll create a new prefab from this. I'm going to drop this into the Objects Harvestable folder, and let's enter into here. So the reason for having a separate game object here is so that we can separate the particle system that we'll add to this harvestable object from the original sprite and original collider and original harvestable script. So the way I had it set up, and there are of course different ways you could do this, is that when the harvestable object, in this case the tree, has consumed all of its resources, then the tree will be destroyed. But this particle system, which is going to be emitting the particles that turn into resource pickups, might have not actually finished sending out all of those pickups when the tree removes itself. So keeping them as separate game objects means you can remove one while the other can still function, if that makes any sense. So let's add a particle system into this. So particle system, and the first thing you're going to notice is that there are pink particles. So hit stop. The reason for that is that in the renderer tab, if we go down to here, that we have no material set. So we need to create a material using a PNG texture. So let's go to the Art Gatherer's Exterior Resources folder if you're using the same pack. Take one of these resources and turn it into a material. You can do that by right-clicking on it, going to Create Material, and then this will create a new material in the folder. So I'm going to call this Material Wood Brown, and I'll change it to Particles, Standard Unlit as the material type. So let's drag in Wood Brown, the texture, into the albedo map, and you'll see kind of a preview for how the material looks up there. But you'll notice that it adds in kind of like black background particles because the rendering mode is set to opaque. So we want to change this to cutout so that we can bring the alpha transparency back in. So now with that set up, we can go to the harvestable object again and bring in the new material. So I'm going to drag this into the material slot, and if we hit play, well, now it's emitting a giant log of wood. Now, obviously that's way too big, so we need to go to the top up here and change the start size to something much smaller. Like, I think we want 0.16 for a 16 by 16 pixel size. Let me see if this texture is also 16 by 16. Is there a place I can see it? Yeah, 16 by 16 if we expand the preview there. So that should be the right size for the particles. And let's hit play. Okay, so we can kind of see particles being emitted of the right size for the wood. Okay, so to keep things a little bit organized, I'm going to take the materials we create and I'll put them into a new folder. I'm just going to put that in the resources folder here. So I'm going to call it materials, and I'll bring this resource material and any other resource materials into this materials folder. The next thing we probably want to do here is kind of bring back the pine tree as a harvestable object. So I will nest that in the scene. We'll start with that. So we have the pine tree object, which is the actual harvestable object. And then we have the harvestable object on top. So the idea is when the axe hits the tree, the particle system is going to emit these wood particles, which eventually turn into game objects. Particle systems don't create game objects, but there's a trick we can do to create a game object at that position when the particle disappears. And we'll get into that in a second. So to start, let's create kind of a kill zone collider for this tree, which means that whenever it exits this zone, that the particles will be killed off and removed from the particle system. So add a component, circle collider, and let's edit the collider shape. This would actually be easier to see if we're not editing it in the same context. So let's exit out of the prefab mode and double click on the prefab from the project window. That way we can see things a lot better here. So let's zoom in. Okay. Well, we do have to zoom in a lot there. Go back to the circle collider, edit it, and let's shrink the size. Okay, so it's way too big right now. Let's take the size and manually decrease that to something like 0.5. Okay, and we still need to make it smaller. So something around the outside radius of the tree. Let's do 0.25. I think that's a good starting point. Okay, so this collider, basically whenever something is outside of it, it's going to kill off the particle. But you can see that these particles are spawning way outside of the circle to begin with. So let's go to the shape tab of the particle system, enter here, and let's do some settings here. So first off, change the shape to circle. So we have a circle for creating the particles and a circle for killing them off. So the important thing here is that the spawning circle is smaller than the kill circle so that the particles actually spawn within the maximum radius. So take the radius and set it to something like 0.2 or even less than that, 0.15. Okay, so now you can see that the particles are spawning from inside of here. I think I actually want it to be smaller than that. So let's do 0.04 or 0.05. I think it's good. Yeah, we can go with that. So now they're spawning from inside of that circle, but their velocity is way too fast. So let's go up to the top, and I'll change the start speed to be much less. Let's try something like 0.5 for right now. That's pretty okay, but let's double that to 1. I think that's pretty reasonable. So now to kill off the particles when they leave this circle, let's go to the triggers tab, expand this, check triggers, and now for this list, we're adding a list of colliders which are going to interact with our particles. You can see that inside is set to kill right now, so I actually want to change that to ignore because we're not killing the particles inside the circle, but when they're outside of the circle. So take the circle collider and add it to the list here. So add one to the list, takes a component. The component we want is circle collider. And now take the outside and turn it to kill. And now when a particle reaches the outside of our circle collider, it's killed off immediately. So the particles can only exist inside of there. So that's the part for killing them. To create the callback where the game object that looks just like the particle is going to spawn, we use the exit and a callback here. But to have a callback, we're going to have to use a script. So in this case, I'm going to take the Harvestable script that is currently on this child game object and move it up to the Harvestable object. So I have one script to manage things, but the tree pine part of this is basically going to be the visuals. And when the tree's removed, it's also going to remove the circle collider used for triggering the particles to spawn. So the Harvestable script won't be able to create any more particles once this object is removed. So let's take the tree, and I'll also Harvestable script removed component apply to tree pine. So this is now just a tree with nothing special about it. Now click on the Harvestable object and let's edit the script. So edit script. So the Harvestable script so far is really basic, but what we really want the Harvestable script to do is not destroy the game object, at least initially, but to spawn particles through this particle system. So to do that, we're going to get access to the particle system. So let's go ahead and do that on start method. So let's write start, and then we're going to do _ps for particles. And then we'll do _ps for particle system equals get component particle system. And when we have access to the particle system, we can tell it to emit particles. And let's, of course, generate the field for that. So a private field for our particle system. So now when we have harvest being called, let's get a int amount to harvest. And then we'll use that amount to decide how many particles we generate. Since the particles will eventually turn into game objects, so we're in a sense spawning one pickup resource for every one amount that goes into the harvest function. So let's not destroy it here. I'll comment that out. And instead we do _ps dot emit, and we just pass in the amount here. So this would allow us to just continually emit particles whenever it gets hit based on a certain amount, but we do want a limit there, which is going to be the basically total number of resources that our harvestable node holds. So we can create a field to set that up. Just how many things do you want one tree or one rock to be able to spawn? So let's do a field, serialized field for the backing field of a property, and then public float. So we could call this something like, let's say, resource count as a get private set, so that you can, once again, not just randomly change this from another script. So with the resource count, we can check if the amount of resources we've spawned has gone above this resource count, and then if it has, then the node is depleted. So we could set it to a depleted state, or just keep it simple and destroy the game object. Let's have a private field for the amount of resources harvested. So private float underscore resources harvested. Of course, this would start at 0, or we could call it amount harvested. Might be a little bit more clear. So whenever we pass in the amount, we can see how many more we are allowed to actually emit from the particle system. So to do that, we need to get the difference between the resource count and the amount harvested. So let's do a integer. And actually, these should really be integer values. It doesn't really make a lot of sense to spawn a partial particle. So we'll just have integer numbers. So 1, 2, 3, 4, 5, no decimal point. So in the harvest function, we'll have the integer amount to spawn, which will be based on a mathf function, and that's going to be mathf.min. So the lower between these two amounts, which is going to be the amount we expected, and the resource count minus the amount that's already harvested. So basically, we can't harvest more resources than are left in the node. So if the amount to spawn is greater than 0, then we can actually emit the amount to spawn. So let's cut this and put it in there. Amount to spawn. And then after we've emitted those particles, then we add that amount that we actually did spawn to the amount harvested. So underscore amount harvested plus equals the amount to spawn. Okay, and up there, get rid of the f. It's not a float anymore, it's an integer. Okay, so after that, and really we could check this regardless of whether or not we did spawn any or not, but if the amount harvested now is greater or equal to the resource count, then the node is depleted. So we're going to destroy a game object in here, but it's not going to be this game object per se. It's going to be the node game object. The one under it, which holds the sprite renderer for the tree or the rock or whatever. So let's get a new field up here. And this will be a public game object. And I'll call this resource node. We'll just have a get. So the only way we'll be able to set this is in the inspector. Don't really need a private set. So let's take the resource node, and we're going to destroy the resource node now. So that will be where we have the collision check for, of course, the tree getting hit. So once it's gone, you can no longer collide with the tree, and you shouldn't be able to cause this harvest function to happen anymore. So since we changed the harvest function, we also need to go to the tool script and give it some value of the amount to harvest. So we could go up here to the top and set something like a minimum maximum harvest values. Eventually, this might be in something else like the tool statistics themselves, maybe in a scriptable object. But for right now, let's do a field, serialized field, and let's add in a public int min harvest, and we'll have a get private set, and we'll set the min to 1. And then let's just copy paste this line, and we'll have a max harvest, and let's say that's 3. So we can have a random number between 1 and 3 be the amount we harvest, which is a little bit more interesting, I think, than just always harvesting one material from the node on each swing. So to generate the random number, we want unity engine.random. Let's see, random range, and I believe you can use integers here, so min harvest as the min, and then max harvest as the max. So it looks like we want random.range instead of random range. So now that we have the random number, let's just pass that into the harvest amount. Okay, and now we should be able to go back out our scripts compile, we should be able to come back out here and test everything so far. So first off, let's take the emission and take the rate over time and set that to 0 so that the particles are only going to spawn when we actually hit the tree. So rate over time is good for testing, but that's not what we want in the actual thing. And then let's go down here to the harvestable script. So the resource count, we can just default this to something like 5. It looks like for the harvestable script, though, in order to actually set it in the inspector, we have to have a private set. I guess I forgot about that. So add in private set for resource node. Then we come back out again. Okay, and we can set that node. So in the hierarchy, take the tree pine node or game object and assign that to the resource node so it can be removed when the harvestable script runs out of game objects. Okay, so now let's go back to the main scene. I am going to delete the extra trees here. So I'm going to just hold shift down, select them all, delete it from the screen, and move this harvestable object that actually does have the particle emission into position. Let's hit play, and when we walk into the area, we can see that it's emitting particles, which is close to what we want, except that that should only happen when we hit the tree, not when we run into the circle. So what we want to do is make it so that the circle collider actually doesn't interact with the axe in any way, or really any other game object. It's only there for the particle physics. So on the prefab for the harvestable object, go down to the circle collider, layer overrides, and we're going to want to exclude layers everything here, as I believe the setting we need. So let's hit play, go back in, and you can see that now that circle collider does not interact with the axe in any way. But if we go up to the tree, then it's still not doing its thing. Okay, maybe the tree pine doesn't have the other collider. Let me take a look there. Actually, the other thing is that the harvestable script really was supposed to be on the underlying object. My bad. So take the harvestable script and just drag it onto the tree pine. Or if you can't do that, you can just add in the script again on the tree pine node. So let's add in harvestable. So we want 5 here. And for now, I guess we can set the resource node, but we might not need that as a field because we could just have the game object destroy itself. And on harvestable object, we remove the harvestable script. So now this harvestable script will be tied to this game object, not the parent one with the particle system. But since we moved the position of the harvestable script, that means we need to get access to the particle system again. So there's a couple ways we could get the particle system. One that would be quick would just be get component in parent like this. But there's no guarantee that that's going to be exactly the particle system we're looking for. So a more precise way might be to come up here and change the particle system field to a public property. So field serialized field, and let's make this public. I'll call it, let's say, capital PS, and then get private set. I'll actually call this particle system now to be a bit more clear. Okay, so now we don't need to use the start function for that, but we'll be assigning it in the inspector. And we just take the property down here. Instead of underscore PS emit, it's particle system emit. Okay, and you know what? We do want to be specific about which particle system we're using. So I'm going to rename this one more time. And I'll say resource emit PS for particle system. Okay, I think that should be good. Okay, so now in the inspector, we can assign where that resource emit particle system is, which is on the parent game object. We're not going to need the resource node anymore. So let's remove that as a field and just do destroy game object in the script, the harvestable script. And let's hit play and test if we can get those to spawn. So we take the axe over to the tree and okay, there we have our particles spawning. That's what we want to see. They go away. And the tree also gets destroyed, but the particle system is still going because that's a parent game object. So last thing for this video, let's have a game object spawn at the position where the particles are removed. So to do that, let's create a new folder, I suppose, for resources. So let's right click, create a folder. Yeah, like I guess we'll just call it resources. And I'll create a new game object here. Or actually, let's create it in the scene. So I'm going to right click in the scene, create empty. I'll call this resource wood brown. Okay, and we'll add a component sprite renderer. For the sprite, I'm going to grab the wood brown sprite. And for now, we'll just leave that as the game object. So I'm going to drag this into the resources folder. And then on our harvestable object, let's go into the tree pine where we have the harvestable script. Okay, so lastly, in order to turn the particles into game objects, we want to create another script. I'll call it game object emitter, and I'm going to be putting this one on the harvestable object parent node. So add a new script. We'll call it game object emitter. Create an add. Okay, in the script, we'll be needing to get access to the particle system once again. And also, we're going to need a prefab to spawn. So this will be the pickup resource that we want to spawn. So field, serialize field, public game object. And we could just say pickup prefab or something. So get private set. And let's also get the particle system. So private particle system underscore PS. On start, we'll get that. So this is going to be from the current game object. So just get component particle system. And then get rid of the update function. And the function we need to respond to from the particle system is going to be on particle trigger. So if we take a look at the particle system in Unity, you can see triggers. These are the different triggers. So the one we're going to be reacting to specifically is on exit, and we're going to set that to callback. So set triggers exit to callback. So then we need on particle trigger inside of this mono behavior script. And we want to get all of the particles that are triggering that exit callback. So let's do underscore ps dot get trigger particles. And we want the particles that have the event type exit. So when the particles exit the radius, they trigger this event and we get the callback. And this will give us a list of particles, which we can use to basically go through each particle and spawn the game object at the point where that particle is currently at. So to set the list of particles, let's create one up at the top. So have private list of particles, or hold on, let me see what's that's technically called. Particle system dot particle. So particle system dot particle, and we'll just have a exit particles as the list name, and this will just be a new list. So just initialize it as a new list. And then let's take exit particles, put that in there. So this function is going to fill the list of exit particles, and then we just go through each one and create a game object. So for each particle system dot particle, yeah, can be particle P and exit particles. Sure, why not? Then we're going to create the game object. So let's do game object spawned object equals instantiate on the pickup prefab. But you know what? I'm going to rename pickup prefab just as object prefab, keeping it more generic since this is game object emitter. It doesn't necessarily have anything to do with pickups. And then we're going to set the transform position of the new game object to the position of the particle. So spawned object dot transform dot position is going to be equal to p dot position. Okay, and that may be able to work. Let's go ahead, go back out to the game view. Let's scroll down here to see our script. So we need to put the object prefab. I'll select an object from the project and the assets folder. So we want the resource wood brown game object. Okay, and make sure we have exit set to callback on the triggers. Now let's hit play. Let's run into the tree. And we can see that the game objects are spawning, but not necessarily at the same position as the particle. So for the resource wood brown, I'm going to make sure all its X, Y, Z values are set to 0. And let's apply those defaults to the prefab. Okay, maybe we'll just double click into the prefab and hit 0, 0, 0. Okay, yep. Let's go back out, hit play, and see if it's working now. Okay, so they're still spawning away from where the tree is at. But at least for right now, we have the basic idea of spawning the game objects when the particles are removed. So in the next part, we'll work on getting them to be in the right position a little bit more, and then actually making it so we can pick up the resources and other stuff like that. So in this video, we want to continue working on our particle spawning and the game objects, and then eventually take the game objects that spawn after the particles are emitted from the tree, and then they turn into game objects over here, and actually turn this into something you can pick up by walking over them. So the first thing we want to do, though, is to fix the spawn location for these particles turning into game objects. So that's actually pretty simple. We need to go into the Harvestable object prefab here, and then where we have simulation space at the top for Harvestable object, change that to world. This is going to make it so that each of the particles have their own independent location transform space inside of the world. So now if we hit play, that's going to fix the spawning of the game objects. So they spawn at the exact location now of where the particles disappear. So it's seamless between when the particle disappears and the game object is set up to replace it. So that's what we're looking for there. If you want the game objects to be a little bit closer to the tree, then we can simply go to the Harvestable object and shrink the size of the circle collider. So let's go down to the bottom over here, and maybe if we make it something like 0.2, then that will be closer to the tree when they turn into game objects. So now if we hit play, it'll look kind of like this. So you can see they end up much closer to where the tree was at. So that's probably a more reasonable circle collider radius size. Another thing we want to improve is that our gatherer, when it hits the tree, should only be able to actually damage the harvestable objects like the tree when we're using the use action animation. So in order to do that, go into the gatherer prefab, and for the tool game object under the gatherer, we need to disable the polygon collider in all cases except when we are using the tool and we have the polygon collider enabled at the exact moment of hitting the tree. So basically, anytime that we're not actively in that state of hitting an object, we can't actually damage the tree or another harvestable object. So if we go to the animation window and we look at our swing animation, you'll see that there's no mention of the polygon collider under the tool for these animations. So we need to set that up, and we can do that by going to add property, do tool, and then choose the polygon collider here and the enabled property. Double click to add it there. You might need to expand the window so that it's actually visible. So polygon collider enabled, polygon collider 2D enabled, add that. And on the first frame of an animation, we want to disable it. So go to frame 00 and disable it. Then at frame 02 for our swing animations, we want to enable it. And then at the end of our animation over here, frame 03, we want to disable the box collider. So now if we hit play, you'll see that the box collider is only enabled at that moment when the axe is actually hitting the object in front of it. So that's going to help us with controlling damaging the harvestable objects. Now you need to do the same thing for the other swing animations, since they all have 3 frames of animation followed by turning things off at 03 when the animations are done. So to select all of these and copy them, hold left mouse button down and drag a box around these 3 keyframes. Control C to copy them, go to the other animations, and paste them with the main cursor at 00. So Control V, paste it in, and now we have the same setup where it's only enabled at 02. So do that for the other animations. Control V to paste it in, swing up, Control V to paste it in. So now the only thing we need to do is to make sure that by default the polygon collider is disabled. So go to the inspector and just disable the polygon collider by default. So now it will only turn on when it's in these swing animations. And because we turn it off after the animation is done, we don't need to worry about customizing anything for the colliders on these animations, which are going to have nothing to do with our object colliding and trying to harvest trees, like walk and idle. So that should solve that problem. Let's go back out and hit play. If we walk at the tree, it's not going to damage it, but if we go to the tree and hit F, you can see that now we have our harvesting working as intended. So now we just need to make it so we can actually go ahead and pick up these game objects and add them to our inventory. So if I click on this instance of the prefab resource wood brown, you'll see that currently they don't have any script attached to them, so there's no information for determining if the item should be picked up and added to the player's inventory. And the player also doesn't have an inventory in order to hold these type of resource objects. So we're going to need at least 2 scripts in order to set this up. Let's start by adding a component, and we'll add a new script. I think I will call it resource pickup. So whenever we want to have an object that can be picked up and added to the character's resource inventory, this is going to have the code in order to do that. So let's create and add our script. But before we actually edit the resource pickup script, let's actually create a resource scriptable object so that we have a item that has certain data attached to it, maybe like the value of the item or the name of it and the icon associated with it, and we'll add that information to a scriptable object called resource. And then when we pick up the resource, we'll attach exactly which resource gets picked up for each resource pickup script over here. And then we add that to the player's inventory. So we need that resource added first. So let's go into the scripts folder. I'm going to right click and create a new script, C# script, and I will just call this one resource. Now, if the resource pickup and any other scripts aren't already in this folder, go to the assets folder and bring them in. So I'm going to drag resource pickup into the scripts folder, and game object emitter, let's put that in there as well. Okay, so we just cleaned up the project. All the scripts are now in one folder. And now let's go into scripts and double click on the resource script. So now let's go into scripts and double click on the resource script. So right now it's being set as a mono behavior, but what we want to do is have the resource be something that can be defined and saved into the assets folder of the project. So it won't exist inside of the scene. This would just be the details of what the resource is inside of the entire game world. So the first thing I'm going to want to do is change this into a scriptable object as something that can be defined and saved inside the assets folder of our project. So this definition for the resource will not exist in the scene, but in the entire project. So the first thing I want to do is take the resource and change it into a scriptable object so that we can define different types of resources in the assets folder of our project. And that means we're going to need a create asset menu. So in the create asset menu tag up here at the top, I'm going to do file name, and let's just call it a resource. And menu name, we'll do the solution name for the project, which is Gatherer Top-Down RPG / resource. You can use whatever menu path you want. That's just how I've been setting it up so far. So now we need to give it the start update methods. Those aren't a thing for scriptable objects. And now we can define what kind of data that each resource asset should store. So let's start with a field, serialized field, and I'll have a public string display name as how we want to display the in-game name for this object in the project. So we'll have a get and a private set. The private set is so that we can not change it from an outside script, but this will be something that is consistent or only editable inside of the resource script itself. And then let's add in another field, serialized field, and I'll do public sprite, and we'll do icon. So get private set. This will be how we want it to display in the UI whenever we are showing the resource. We'll have this icon show up to represent the resource. And then maybe we want some other fields like field, serialized field, public string description, get private set. And you can add as many extra fields that all resources should have as it applies to what you want your game to be. So for instance, another one could be field, serialized field, public int, or maybe a float for value, get private set. And then now if you're going to have any kind of currency system going on in your game where you buy or sell resources with money, then now you have a value property that you can set the value of what 1 unit of this resource should be. So feel free to add as many extra details to your resources as you need. If you want to create a secondary class of resource, you could always inherit from this resource class and then add extra fields on top of it. If there's supposed to be one type of item or resource that has certain data associated with it that the rest don't need, then you can do that as well. You don't have to have every resource have every single field. But this is a good basic start for what we're going to do in our project. So let's go out to the project and let's open up, let's say, the resources folder, and let's right click here, create a new Gatherer Top-Down RPG item, and we'll do resource. So the resource here was going to be resource underscore Ward Brown, and hit enter. So this resource file is different than the prefab here. The prefab is for the game object that exists inside of our scene. And then the resource scriptable object is for storing all of the data that whenever we need to reference this resource as a unit of something in the game, these should be the details for it. So for instance, for the display name here, we could say brown wood. For the icon, we can look for the same sprite that we're using for the game object. So wood brown. and add that in there. And then for the description, we could say basic wood for building furniture and buildings. And then for the value, we could just set to 1. So whether you're using gold or whatever as your money in the game, it has a value of 1. Okay, so we have this resource, and we have the game object for the resource. So let's make it so that when we pick up the game object, remove the game object from the scene, we still add it to the player's inventory as that scriptable object resource file. So for the resource wood brown we have in the scene, we want to make sure that all copies of resource wood brown have this new resource pickup script. So let's remove the component, and I'll double click into the prefab. Let's add it here. So resource pickup as the script. Doesn't seem like it's being recognized here. We might need to go and edit it first. So in scripts, let's double click resource pickup. I'll go ahead and Control S to save it here. And yes, we can see that the domain is reloading. So now that that's done, the script should be recognized, and we can add it as a component. So resource pickup is what we want here. Now we need a field to have that resource scriptable object be able to be set here, and then we'll be able to pick that up to the player's inventory. So inside of the resource pickup script, let's add in a property with a field backing it. So a field, serialized field for the backing field, and then public resource. And you do want to be sure that this resource class we're talking about is the resource class that we're writing, not any other default resources that may exist in the Unity engine. So just be careful about that if you ever get any conflicts. So now we need to name the property. We could give it resource type, get private set. Okay. And now we just need to have a trigger where when the player walks into the resource pickup radius, either the player's inventory just picks up the resource or the resource adds itself to the player's inventory. But logically speaking, I think it makes more sense for the player with the inventory to pick up the resource. So we'll add that in an inventory script rather than on this resource pickup script. So let's go back out to the Unity editor, and you can see we now have this field we can set for the resource type. So let's select a resource type. We have resource wood brown, and let's go back out to the main scene and enter the gatherer prefab. So an inventory is something that there's a good chance different characters in our game are going to want to have. So we can make it a separate script from the player controller so that enemies or players or NPCs that might want an inventory can just add it as a component, and we don't need to just add it straight into the player controller script, which is obviously only going to be used for the player. So let's add in a new component here, making sure we're in prefab mode, and let's call it either inventory or resource inventory, whatever makes sense to you. We can just do inventory for right now and create an add. So let's edit the script. So for the inventory in this game, I'm going to want it to be able to hold a list of all the resources and the count of each of those resources that we have collected. So earlier in the project, I used Unity Serializable Dictionary in order to set up stuff like state animations, linking a character state to a directional animation set. So we can use the same Serializable Dictionary in order to set up the inventory. So if you haven't already added the Unity Serializable Dictionary to your project, you can easily find it on GitHub. And this plugin is by As6, Mick Azzy, if I'm saying that right. Unity Serializable Dictionary. And then once it's in there, we can do this field, serialized field, public, serializable dictionary, and we give it a type. And the type of this dictionary is going to be the key, which is resource, and then the value, which is a count integer. And then let's call this dictionary resources with a get private set. Now if we take a look back out in Unity, we'll see that we have this resources dictionary, and it's serialized here. So we could add it and give it a type of resource like resource wood brown and set a count like 5 to it. So the thing here is I don't want to start with the resources added. I want them to automatically add themselves after we pick them up. So we're going to need to write a couple functions for our inventory script. So what we're going to want to do in the inventory script is make it so that we have to set the resources through a custom method we set up, which is going to see if the resource already exists inside of the dictionary. And if so, we're going to add the new count of resources we're adding to the existing count of resources that already exist. Otherwise, if the resource isn't in the inventory, then we create a new key value pair inside of the dictionary and just add that in. So because of that, we don't really want to be editing the resources directly from other scripts. So I'm going to take the serializable dictionary here, and we're just going to make it private, and that's going to be for both the get and the set. So we'll Control S, save that, take a look out in the project, and we can still see that we have the serialized resources dictionary. But now we need to create some methods for a custom way of accessing the resources inside of this script. So first off, I'll create one for getting the amount of resources inside of the script. So this would be a public int get resource count. And let's see, we're gonna need a type of resource. And then we'll do a check if we actually find the resource type in the dictionary. So we'll do resources dot try get value. Okay, and this is going to be using the key. So the key is the type, and we're going to out this to an integer value. And this will be current count. And we wrap this in an if statement because try get value returns a Boolean. So we can use that to go into this code where we just return the current count if it exists. Otherwise, if it fails to find the key, then there are none of that resource in the inside of the serializable dictionary, so we'll just return 0. So that basically serves for getting the resource count if we need to know that in any other script. So now let's work on setting the resources inside of the resources dictionary. So we can make a new function. So I'll make this a public int so we can return the new count after adding the resources to the dictionary, and we'll do add resources with a resource type and a int count to add to the dictionary. So for setting the resource dictionary, what we can do is take, let's say, resources at the type index and plus equals the count. And I'm not totally sure if this will work as I think it will. Basically, check if it already exists. If so, return the current count and add that to the new count we're adding to it to get the final value. And if this is the first time we're adding, then it's going to start with a 0 and add the count in. So we want to take all that and return it. And we'll be able to see if that actually works by going around and picking up the different objects on the screen. So in terms of using the inventory, we could add the ability to pick up objects straight into the inventory script, or we can separate that into a different component script, which might be preferable because maybe not every character that has an inventory should also be able to pick up objects by themselves. So let's add in another script inside of the Unity inspector. So with the inventory, we're going to add a new script. I guess I'll call this the pickup resources script, create and add. Okay, so now to have the pickup of resources be a separate script, let's take the gatherer main object, add a component to it, and let's add a new script. I'm going to call it pickup resources, not to be confused with resources pickup, which is the actual thing we're picking up. So create and add this script, and let's go ahead and edit the script. So here we need access to the inventory component. I don't want to necessarily force the inventory to have to be on the same game object. So to be a little bit more flexible, let's add in field serialized field, public inventory, and we'll call this inventory get private set. And maybe we even call it resources inventory, because this is only for picking up resources, nothing else. Okay, now get rid of start and update the inventory. We'll set that manually in the inspector. And then we need to check when our capsule collider of the player, or any attached collider to this game object, goes into its collision with another game object. So since the pickups are going to be in trigger mode, I can't remember off the top of my head if we need on trigger 2D for entering the radius or on collision 2D, because this collider is not a trigger collider, but actually just a physics collider. So let's start with collision enter 2D. If that doesn't work, then we'll do on trigger enter 2D. And then when we collide with something, we just need to check if its type has a resource pickup component. So let's do resource pickup, equals collision.gameObject.getComponent resources pickup. If the pickup is valid, then we're going to add it, whatever it's containing, to the inventory. So inventory.add resources. So the type of resource is going to be the pickup dot, let's see, what do we call it? Type, resource type. And then the count is going to be 1. Since, at least as things are set up, the pickup only has 1 item inside of it. You could add count to resources pickup if you want to be able to pick up more than 1 item from 1 game object, but that's kind of up to you. So we're just going to add 1 resource to our inventory. Okay, so now in the gatherer, let's go down here. We need to set the inventory, so I'm going to drag the inventory script into here. We already have the capsule collider, which is going to be used in this pickup resources automatically, since these already get the message from the same game object. So whenever the collider actually collides with something, anything that's on the same game object will be able to run this on collision enter 2D. Okay, so with all that done, we may be able to get this to work. So let's go ahead and hit play, and let's start harvesting these tree objects. So I'm going to hit F. We get a game object to spawn. I'm going to run into it, and nothing yet. So what's missing from our resource wood brown, if we check the instance and the prefab, is that it actually has no collider yet. So let's add in some kind of collider, I guess a circle collider 2D. Let's add this in, shrink the radius a little bit. So 0.06 is pretty good here. And I'll set is trigger on. Since this shouldn't be a physics object, it should only be used by triggers for getting picked up. Now if we hit play, we'll see if our character picks it up. And it looks like it's not picking up the object still. And that's probably because it requires onTrigger enter 2D, as I suspected. So if we go back to the script now, it's a pretty quick fix. We'll just do onTrigger enter 2D, and then we copy paste this code down here. And we can remove onCollision enter 2D, since that is for physics objects interacting with physics objects. And basically the same idea. When a trigger collider enters this area, we'll see if it's a resource pickup and then add it to the inventory if so. And one last thing I did forget here, we should also destroy that resource game object. So destroy pickup.gameObject. We can do that here. So let's go to the game view, hit play, and okay, we can see we got something here. The given key was not present in the dictionary, so it was trying to add it to the inventory, which is good. But we got to go back to the inventory script and change this a little bit. So first we got to actually validly check to make sure that the resource is in the dictionary. So we can use that if resources try get value bit again. So let's do if resources try get value. So then we have the count that's in the dictionary, which in this case we can do this resources type plus equals count, which should be the same as doing resources type equals current count plus count. But if that's not the case, then we're adding the first resource to the dictionary. So let's do resources.add type and count. So that should set up the dictionary to have a key value pair for this type now. And then we want to return the count that we just added to that. Okay, so this should be our only 2 cases. Let's go back out to the game, hit play, and see if it validly adds to our inventory. And considering that it disappeared from the screen, I think it probably worked. So let's check the hierarchy, go to the gatherer, scroll down to find our inventory, and you can see we have 1 unit of the resources brown. Now to make sure that this still works after we collect more items, let's hit the tree. So I'm gonna go up to it, press F. Now let's pick up these game objects, run into it. Okay, we have 2 wood brown resources now, and now we can come down here, collect another one, and we can keep harvesting the tree until we've exhausted it of all its resources. Collect these resources. So we have 5 wood now because I just picked up 2. We get this last one. So now we basically have the harvesting set up for harvesting trees inside of our game and adding the wood resources to our inventory. Okay, so now that we can go around and actually collect the resources, it would probably be handy for our player if we didn't have to run to each one and individually pick it up all the time. But if we had something like a gravity well, where our player just kind of sucks in the different resources to the player, just making it easier to collect all the resources on the screen. So if you want to add something like that, then we can create a simple script for it, going into Gatherer. And then I want to have another game object here because we're going to have its own collider, which should only be for the gravity bit. So I'm going to right click in here, create a new empty object, and then let's call it resource gravity, and add a component. We'll do a circle collider. Give it a radius around how far away from the player you want to be able to suck in resources. So that's pretty far right there. I might do something more like 0.25 or 0.35. 3.5 right now I think is good. Now let's add a component which takes advantage of the circle collider. So let's add in a new script. I'll call it, I suppose, something like pickup gravity. And let's new script, create an add. For these scripts we've been creating, make sure that you do move them into the scripts folder to keep everything organized. And now open up the pickup gravity script and we can start editing it. So the first thing we want to do is get a list of the game objects, the pickups that are within the radius of our gravity collider, and then adjusting their position, moving them towards the center point of the pickup gravity game object, which should theoretically be the center point of our character as well, though it doesn't have to be. In order to do that, let's start by having a private list of, let's say, resource pickup. So to get things started, let's maintain a list of resource pickups that are near our players. So private list nearby resources equals a new list. So we just initialize it when the script starts. And then when on trigger enter happens, we want to check if the thing nearby is a resource pickup and add it to that list. So on trigger enter 2D, let's get the resource pickup component if the collision has one. So resource pickup equals collision dot game object dot get component, and that's going to be resource pickup. So if pickup is a component on that game object, then we're going to add it to the list. So nearby resources dot add. Okay, now the other thing that could happen is that the object leaves the radius. Maybe our player is walking too far away from the pickup, so we should stop trying to suck it up. So on trigger exit 2D, we'll do basically the opposite. I'll just copy paste this information here. So all these lines down here. And then if the pickup is valid, we're going to remove it from the list. Then the last thing we need to do is on update, or I guess this would be more like fixed update. We want to change the position of these nearby resources. So I'm going to be doing it directly on the transform. These resources don't have a rigid body, so adding force to it might not make sense. So we could just move its position as a set amount towards the player on every frame or every fixed update. So let's do fixed update here, private void fixed update. Okay, and then for each resource pickup in nearby resources, we want to move it towards the center point of this game object. And to do that, we're going to need a speed of the pickup gravity. So let's make that a field we can set in the inspector. So in square brackets, field, serialize field, public float, and we can call this gravity amount or gravity speed. And let's do get private set. Okay, so now we just need to move the location of the pickup using the gravity speed, the time between frames, and getting the direction. So first off, direction to center. Let's do vector 2, direction to center, I guess. So to get that, we want to subtract the position of one object from another. So the direction to the center, I think that's going to be transform.position minus the pickup's transform position. And then you normalize the vector, stripping out the magnitude. The magnitude, when you normalize it, is always going to be 1, so it's just a direction. Okay, and then we can take the pickup.transform.translate, I think is what we want, to move its position to a new position. So with translate, we're going to be giving it the move that we want it to do. So that's going to be equal to direction to center times the gravity speed times time dot fixed delta time in order to scale it to each frame. And that might be it. So let's go out and test. So in the main scene, I'm going to move the player a little further away. If we expand the player game object, we can click on resource gravity and we can see that this game object of the wood is actually within the radius of our player. So I'll hit play, and you see that it actually instantly gets picked up, which isn't what we want. So let's go back out to resources gravity and make sure this is trigger. So let's hit play, and it looks like the gatherer is still immediately adding it to the inventory. So for right now, I'm just going to disable pickup resources so that we can see what's happening without that. Let's hit play, and we can see that the object is not really moving right now, probably because we haven't set the resource gravity. So let's set it to a gravity speed of 1, hit play. Okay, and now we can see that it is definitely getting sucked into the main position. Too fast though, so let's turn the gravity speed to 0.25. So now if we hit play, we can see it's moving to the player a lot slower. When it gets to the player, it doesn't get picked up because we turned off the resources pickup. But the pickup resources script, if we re-enable that by reverting, and we hit play again, you'll see that it automatically grabs the resource when it's inside of this resource gravity radius. So we want to make sure that the pickup resources actually only picks up the resource with a specific collider. So I think one good way of handling that might be to jump into the prefab, and we'll also put pickup resources on its own game object so that it only uses its collider and not any child colliders. So I'm going to right click. Let's go to create empty. And I'll just call this one pickup. For the script pickup resources, move that to the pickup object, and then add a new collider, circle collider 2D. We'll shrink this down to something very small like 0.05, is trigger mode, and now pickup resources should only be using this collider for actually picking up objects like the resources. So if we go out to the main scene, we can confirm that the pickup game object has the pickup resources script. And if we hit play, then now the pickup is not actually collecting the wood until it gets within range of the player. So that's more the behavior we're looking for. So both the resources work, but the pickup also works because now they're using their own separate colliders. Another option that you could do if you want with these kind of scripts is to attach a collider to the script and then check that when a collision event happens, that it was specifically this collider that you wanted to use for determining if a resource is picked up or not. So basically only if the collision happened with this circle collider does it get picked up, but then you might have too many colliders in one game object as well, and that could get kind of confusing. So for right now, I think I prefer this kind of separating things up into their own different function under the main gatherer game object. Okay, so now I think the last thing to do is just to figure out what value we want the gravity speed to be set at. So I think the way this is working is units per second, or how many pixels, where 1 is 100 pixels per second that we're moving it towards the player. So I'm going to go into edit the script, and let's default this to 0.1f for 10 pixels per second. And then in the gatherer prefab, I'm going to change the gravity speed to 0.1 as the default as well. In the gatherer instance, I'm just going to revert to the prefab value. And now if we hit play, we can see that it moves very slowly towards the player. But I think that the pickup radius is actually a little too big. So on pickup, let's shrink this radius as well. So let's do 0.02. And I might even move the position up, let's say 1 or 2 pixels, just so that the place which it's sucking in is more of the center point of our character, not down here. And we can also adjust the transform of the resource gravity script as well. So 0.02. Now the pickup circle is a smaller circle with the same center point as the resource gravity. So I think that will make some more sense. I also want to turn up the resource gravity a little bit. I think I toned it down too much. So let's do 0.2. I'm going to apply to the prefab. And let's change the script default to 0.2 as well. So now if we hit play, the wood will get sucked in and go into the inventory at a more appropriate point. So I think that's about it for creating pickup gravity for our character. Okay, so for this next video, I want to take our harvestable objects and give it a particle explosion effect whenever the node is depleted and we remove the node. We want some kind of effect to appear on the screen, spread out some particles, and show that the object has been completely destroyed. So for the duration of this video, I'm going to take the count that the harvestable object on the screen here, this tree pine, can harvest, and we'll take the resource count down to 1 just so that we hit it once and it will be destroyed. And let's also remove this wood brown resource from the screen. Those are being generated by the tree being destroyed or harvested, so we don't really need that instance on the screen anymore. So now if we hit play, we go to the tree, we swing at the tree, it gets hit once, and we only get 1 wood to come out, but that should be good for testing our particle effect when it gets destroyed. So where I'm going to want to create that particle effect is just a game object instance that we can spawn here. So we'll use a prefab and we'll create an instance of that, and that game object will have the particle effect on it. So to get the field for creating the prefab instance, let's go to the Harvestable script down here, edit it. And when we destroy the node, we also want to first instantiate the effect. So let's go ahead and do that. Up here under, let's say, the particle system, let's add in a field, serialize field, public game object, and we'll call this prefab effect on destroy prefab get private set. So down here, the node is depleted. If we have a effect on destroy prefab, then we're going to instantiate it at the position of this harvestable game object. So let's see, instantiate effect on destroy prefab. And we're not going to set the transform parent, but we actually want to set the position. So let's do transform.position here. And then with this version of the function, we also need a quaternion rotation. So we'll do quaternion.identity, which just means use the default rotation, which is basically none. And we're going to instantiate that game object at the transform position of the harvestable game object. And we just do that before we destroy the game object. So now out here in the harvestable script, we can set that prefab object if we want to create a effect when the harvestable is destroyed. So let's create a new game object in our scene, and then we'll create a prefab from that. So right click, create empty game object, and I'll call this explosion particle effect. And in our project, I guess this would make sense if we put it in a folder. We call it effects. So let's do that. Right click, create a folder, effects, double click into the folder, drag in the explosion particle effect prefab into here, and let's double click on it in order to edit it. So first off, reset the position to 0, 0, 0, which should be the default position for it, and go back out to the main scene, and I'll also reset the position here just in case. Let's jump into the prefab one more time, and we need to add a particle system. So add particle system. Once again, we can see there's no material for these particles and they're way too big. And let's take the speed down to 1, the start size down to something like 0.08, which would be an 8 pixel wide particle. And then for renderer, we need to set a material for these particles. So I'm going to right click in here into the effects folder, create a new material. So I'll call this material explosion particle. Let's change it from spritelit default to particles, and let's say standard unlit for the albedo map. So for right now, I'll just leave it as a square particle. Let's add it into the explosion particle effect. So click on the prefab, go to renderer, and drag in material explosion particle. Let's also double click on the explosion particle effect so that we can kind of see it occurring here. So that's what it looks like so far. They're kind of slow, and they probably actually are spreading across way too wide of an area. So I'm going to go down to shape, and let's change the shape to circle. I'm also going to change the radius of the circle to something much smaller, like 0.2. Remember, this is in game unit sizes, so that's already 40 pixels wide as the spawn location for the particles. And then I want them to only go downwards from where the tree is at. So let's do an arc of 180. And I'm going to hit E to go to rotation mode, and let's rotate that arc downwards so that the particles can only spawn downwards from where the effect is happening. So like that. So, and okay, I guess I didn't do it perfectly, but you can see the spawn line here. They only go from there. So we need to rotate it more on the Z axis and just get it to snap into place where we're only doing the bottom 180 degrees, not the top 180 degrees. So anyway, E to rotate, and then you rotate on the Z-axis until you get it to be roughly like that. Okay, so if we hit play, that's what it's looking like. The particles are going to be way too big, I think. And we could kind of test that actually by going out to the main scene. Let's click on the harvestable object, and let's go to the prefab, click on tree pine, and then effect on destroy prefab, drag in the explosion particle effect. If we hit play, we can go over to the tree, hit F, swing at it, and you'll see that a new copy of that particle effect spawns here, but it's not really facing the right direction, and the particles are way too big. Let's also go to the main scene and remove this explosion particle effect. That shouldn't just be there constantly. Gonna jump into the prefab explosion particle effect. So if we look at the values here, we can actually see when I rotated the transform, I was rotating the particles transform, not the shapes transform. So this actually gets reset to 0 when we use quaternion identity. So let's set that to 0. And we need to actually rotate this shape. So I guess we'll try these gizmos editing modes here. So if we do this mode, we can click on the rotation here and rotate it down. Yeah, we can also just set the field values here to 180, which I guess would be a more precise way of getting the same thing. So if we hit play, we can go hit the tree and we'll see that it's now facing the right direction at least. Okay, let's shrink the particle size. I'll make it more like 0.02. And remember, we're adding this in the prefab so that it updates everywhere. So the speed is probably okay, but the lifespan is too long. Let's take the lifespan and make it more like 0.25 seconds. So after spawning, these particles go away very, very quickly. And the other thing is we don't want a constant emission of these particles. We want a burst emission. So it should all basically happen in one go. So I'm going to stop here. Let's go down to emission. And for rate over time, set that to 0. Then there's this field here for burst. We want to add one to the list. So I'll have a burst at time 0. And we could say 30 particles if we want. So if you hit play, then you'll see that whenever we hit restart, we get those particles to come out at one go. Okay, so because this effect is supposed to go away, one way of quickly making it so that after all the particles are gone, we can just have it remove itself from the scene is if we look at the list here, stop action. So you want to take the stop action and set this to destroy. So if you hover over stop action, when all the particles have died, what should the game object do? And we want it to destroy itself. Okay, so now basically if we hit play, we can test our particle effect. We'll go up to the tree, we'll hit F. And you'll see a bunch of particles spawn, but that particle effect, well, should already be gone. But I think it's in like looping mode right now. So yeah, we can see it is looping. So I'm going to turn off F. Let's go into the prefab, turn off looping here. And duration, I don't know that we actually need to set that. Let's hit play. Let's test this one more time. I'll go to the main scene, watch the hierarchy, hit F here. We see the particle effect spawns, but it doesn't immediately remove itself. It takes 5 seconds to do so. So I guess we do need to set the duration. So if we hit restart, we can see that they're gone by about half a second. So I'll take the duration and let's set it to 0.5 or 1. As long as we give it enough time for all of the particles to go away, that should be fine. We can see that the particles have a lifespan of 0.25 seconds. So 0.5 seconds should be more than enough. Hit play, go here, hit F, and you can see that by now the particle system has already destroyed itself from the scene. So that's basically working there. It's just a matter of tweaking the particle effect to have the right amount of particles and the right size of the particles as you prefer. So you might want to go into emission, decrease the amount of count, and then increase the particle size to something like 0.04. Hit play to test, and then that can be more like what we're going to get. Other options we could play around with could be fading the particles out over time, or if you want to give them a color, you can do that. So if you just want to do the fade out over time, then we can do color over lifespan and click on the gradient. So over here at the right, we'll just turn the alpha to 0. So now if you hit play, the particles should kind of fade themselves over that 0.25 seconds. There might not be enough frames to really see that. Let's go ahead and test. Hit F, and it's pretty hard to tell, actually. Instead of that, we could try changing it to a different color. So if you click down here on this notch, we can change it to like a gray color over time. Hit play, go here and hit F. Okay, and then you can see that they turn into gray over time. So maybe we want a gray and fading out. Then we can hit play and kind of test that. So that looks a little bit better there, probably more clear. Maybe you don't need the alpha at all. Maybe you can just do it purely by color. So if you want, we can take the alpha to that. You could even use something like this preset if you want it to be like a fire-based particle effect, if that's there for you. If it's not, then you can just choose some colors, put it in the gradient at the times you want the colors to be the color that they are. So you could start with white, and you can end in a kind of like a gray, and then in between, maybe it's more towards white as well. So you can set if you want it to only get gray towards the very end, or if you want it to be gray towards the beginning, so more of a clean blend between those two colors. Or you can just remove this notch completely and just have it fade between two colors. So if we hit play, you can just keep testing it. Hit play to go into actual play mode, not just visibly looking at it. And just see if that's kind of like the effect you're going for. I think I still want there to be alpha fade, so I'll add that in there. I do think I know why the alpha is not fading away. If we click on the material particle, it's because we're in opaque mode. So if we make this cutout, now let's click on the explosion particle effect in the scene, hit play, and yeah. Now you can see it fades away very, very fast. I think that's because the transparency actually is able to fade. So if we hit F here, yeah, it definitely looks like they're fading. So that might be too quick for that. Maybe we make it 0.35 seconds, go into play mode, hit play, okay, and we get our explosion outwards. With that, I think I'll take the color and just put it back to white. I think transparency and color fading is a little too much for one go. And yeah, so if we hit play, we can go up here, hit F, and we have a decent particle explosion effect that removes itself when it's done. So other things you could change around with, if you want to add a shape to the particle, then just drag some kind of simple pixel art shape into this albedo map. For instance, in the art pack, I had that pixel particle shape. So if let's see if I can zoom in here. I guess I can't. Let's open it up and view it. You can see that this is just a really simple shape that's just a little different than just having a simple square. So you can make or use something like that and just drag that into the albedo map for your particle if you want it to be a different shape than just a square. Okay, and that's basically in a gist what you need to do to create a explosion effect when your harvestable object is removed from the scene. So up to this point, we already have the basic harvesting mechanics of our character, being able to swing a axe, hit a tree, recover the wood, and the tree will explode after we are done harvesting it. But what we want to do next is set up a new harvestable object with its own set of resources. And also to differentiate between the harvestable objects, we'll have different tool types. So right now we're using a lumberjack's axe, so it makes sense that we're harvesting a tree. But if we set up a rock harvestable, then it would make much more sense to be using the pickaxe tool in order to harvest it. So we'll need a mechanic in order to check if we're using the pickaxe or the axe, and then only allow those specific tools to harvest the rock or the tree correspondingly. So let's start by setting up the rock harvestable object. This harvestable object in the scene, I'm going to delete that instance. And then let's go over to the assets objects folder, harvestable, where we have the harvestable object inside of here. So what I want to do with this harvestable object is make it the root prefab for any future prefabs we create. So we want one prefab for a harvestable rock and one for a harvestable tree. So we're going to want to set those up. So let's drag one of these harvestable objects onto the scene. I'm going to rename this harvestable object to be harvestable object underscore tree pine. And now let's drag it back into the harvestable folder and then choose a prefab variant. So when you have a prefab variant, it means that this is based on the original prefab of the harvestable object. And we can override settings in the harvestable object, but by default, we're going to inherit the defaults from harvestable object. So it's just that the harvestable object are now the defaults, and then any modifications will be set on the variant. So I'm going to rename this and get rid of the variant part, since the tree pine part already kind of defines that. And now let's drag a new harvestable object onto the scene. And I'm going to rename this one to be, let's say, large rock. And I'll drag it into the harvestable folder under assets, objects, harvestable, prefab variant. Okay, so now these two variants are based on the original. So if we need to make a change that applies to everything, do it on harvestable object. And if you need to edit something specific to the variant, then do it on the variant prefab. So let's rename large rock variant, remove the variant part. And now we can double click into the harvestable object large rock. And then let's rename the child node to be something more like resource node And I'll also do that on the main harvestable object. So resource node down here, and now that will be the default name whenever we create a instance from that prefab. If we look at tree pine, you'll see that it has already been renamed here as well. So go back into the large rock prefab variant. Let's take the resource node and let's assign a sprite to it. So if we select here, I'm going to search for rock, and we should have a few rocks in the project from the art pack. So let's select a rock we want to use. We can go with this rock large 2. And now let's change the settings for this prefab variant. So first off, with this circle collider, I want to remove it and replace it with a capsule collider. So we can have kind of an oval shape around the bottom of the rock for where we can harvest the rock. So let's remove the circle collider. I will add a component, and that will be the capsule collider 2D. Okay, and I'm going to take the direction and make it horizontal so it can be wider than it is tall. Let's hit edit, move the top down to right around here, and the bottom up here as well. Probably something we want to change here in advance is going to be the sprite sorting pivot of the large rock. So I'm going to click here and then click on the large rock prefab. Let's go into the sprite editor and set a custom pivot. So I'm going to pull this down to where I think would be a good sorting point for the rock. So that will be kind of at the center of the base of the rock, probably right around there. So 0.5 for the X and 0.32, let's say, for the Y. Hit apply, hit X. Okay, now if we look at this prefab, and let's hit save if it pops up there for unsaved changes. Go to the resource node, and you'll notice that the pivot moved up a bit. So we're going to need to adjust the capsule collider as well. So let's change the offset on the capsule collider and move that up. Maybe it just needs to be 0 there. No, a little bit more than that. Let's go with 0.02, 0.1. Oh, 0 actually works pretty good. Okay, the offset for the X, I'll change that to 0. And now I'm going to do edit collider. Let's bring in the sides a bit for this capsule collider to something like that. It's not perfect. If you want to be super precise, you could use a polygon collider, but this should be okay for this shape of the rock. So we'll go with that for now, and you can always change it later if you need to. So now let's hit play and kind of test what we've got. We've got this rock over here. We can go up to it, have the normal axe, hit the rock on the side, and it's going to generate those wood particles. Just to test, we can come over here to this side as well and get the same effect. And the rock can harvest 5 resources. So next, of course, we need to change the type of resource that it's harvesting. So to do that, go into Assets Resources, where we have the resource wood brown prefab for the game object and the scriptable object resources wood brown. And let's duplicate both of these, Control C, Control V, but we're going to change the sprite that is in here for both of them. So I'll copy both of them, and then let's rename it to be resource rock, and then down here resource rock as well. Okay, so let's select the sprite, and we're going to be looking for a rock sprite, so that's going to be rock item here. Now go to resources rock and do the same thing. So let's change the name here to rock. The icon will be rock item. The description will be let's say basic stone resource for buildings, and the value can just be 1 as well. Okay, so if we look at the rock item PNG, you'll see that it is 8 by 6. So what we're going to want to do is take the particles that are being emitted and make them smaller as well to match the size of this rock item. So let's start by creating a new material under resources materials. So we have material wood brown here. I'm going to Control C, Control V to duplicate that, and I'll rename this to be material rock. Let's change the albedo map to rock item. Okay, so you can search for that in the project, drop it into the albedo map, and that's probably all we need here. So now click on the harvestable object large rock from the prefab variant and the hierarchy. Let's go down here to renderer on the particle system, and let's select the new material. So in the project window, under resources materials, we have material rock. So let's put that in here. We can hit play to test. Okay, and then I think for the size as well, we want to shrink that to 0.08. So we'll see how that goes with the size of the rock. Let's scroll down to the bottom as well. So we have the game object emitter. We want to change the game object that we are replacing the particles with. So now in the resources, assets resources, that is, take resources rock and put it in the object prefab. So now it's going to be replacing the particles with the rock item. So let's hit play. Let's go over here, hit the rock, and we can see them being emitted from the rock shape, and then we can collect them. Now, I think the last thing we need to change on resources rock is we need to change the resource pickup from resource wood brown to resources rock, and then that will add the correct scriptable object item to the player's inventory. Let's hit play now. Exit out into the hierarchy, click on the gatherer, and let's scroll down to see the inventory. So we have our resources dictionary down here. Let's collect some rocks. I'm going to hit this a few times, and we get the rocks added to the inventory. Notice it's resource rock. Now let's collect a tree over here with the different prefab, and that gives us a new dictionary entry. So our inventory now has 2 types of resources. Okay, so now we successfully have 2 types of resource nodes that we can duplicate in our game. So anywhere you want there to be a rock resource, you can just duplicate it. So let's just duplicate some of these trees, and then those will all be harvestable for the player. So if you add a bunch of these harvestable objects to the scene, you might notice the hierarchy gets kind of cluttered. So I'm going to right click and I'm going to create an empty game object. I'll call this harvestable nodes. And let's take all of these harvestable objects and then let's put them under harvestable nodes. So just keeping things organized, you can click on harvestable nodes and see all of the child game objects with their colliders here. And we can collapse the menu to keep our scene a little bit more organized. Okay, so lastly, we need to have those tool types set up so that we can only harvest a rock with a pickaxe, and we can only harvest the tree with using a lumberjack's axe. So let's create a scriptable object for tool types and then use that across our project for checking if the tool type is correct. So in the scripts folder, I'm going to right click, create a new script, C# script, and I'll call this tool type. Open it up. First thing we're going to do is change it to type scriptable object. Remove the start and update methods, and let's create a menu item so that we can create the different types of tools in our assets of the project. So create asset menu, and then as a property set file name, and we're going to set that to tool type. For menu name, we're going to set that to gatherer top down RPG / tool type. Okay, so now we'll be able to right click in the Unity window and to create our assets for the project. So the tool type, we can add some fields to it to define more about what this tool type is. So let's do a field serialized field, and I'll do public string display name with a get private set. So how we want it to be represented in the game by a string. And then we can have a icon field and property. So serialized field, public, let's see, sprite is what we want, and then icon get private set, and maybe we want a description as well. So field serialized field, public string description, get private set. That should be good for right now. You can always come back in here and add extra fields for data that you want to store in a tool type. So let's go back out to the Unity project. In the assets folder, let's right click and create a folder. I'll call this tools, I suppose. Now let's double click into the tools folder, right click, create, gather top down RPG tool type. So the first tool type is going to be a axe. So tool type axe. Let's right click, create a new tool type, and then it's going to be pickaxe. So for the display name, I want it to be pickaxe. For the icon, let's search for the pickaxe sprite. We can use either of them, copper, gold, or silver. I'll just do copper for right now. And then we'll say for the description, used for harvesting rocks and ores. Okay, now for the axe, we'll do something similar. I'll just say display name axe. The icon, let's search for axe, and we'll select axe copper. And the description will be set to used for harvesting wood resources from trees. Okay. So now we have these 2 different types, and we can use these in our scripts in order to check if we are using the right tool type. So first off, on the gatherer, we want to go into the tool game object, and we'll do this in the prefab, but the tool script is going to need to have a tool type associated with it. So what I think would be handy is if we can actually just drag and drop a tool into the tool script. But these are tool types. So we'll have a tool that will have a field for a tool type in case we have different tools of the same type, but we'll set that into the tool script. And actually, I think I want to rename the tool script to something different. So this will be more of a slot to hold the tool. And then we'll have a actual tool as a scriptable object over in our assets tools folder. So let's edit the tool script. And I guess I will change the class name here to be a harvesting component because it's used for harvesting if we are holding a tool. And then we'll need to rename the class name as well. So rename tool to be harvesting as the function we're adding to the player. Okay, so let's make sure we go back to Unity. So let's make sure we go back to Unity. It reloads the domain and we have the harvesting script here. And then let's create a new tool script. So I'm going to right click in the scripts folder of our solution, add a new item, which is of course going to be a C# script, which I will call tool.cs. Let's add that in. Remove the namespace and then make the class a public class. I'll take this part and move it over to the left by selecting it and then shift tab to undo a tab, moving it to the left rather than the right. And now this tool class, the new one, is going to extend scriptable object. So if we take a look back at the harvesting class, you'll see that we had a min harvest and a max harvest set for each different tool. I think that would be useful to have as a customizable field for the tool class rather than putting it on the harvesting as well. So different tools can harvest at different rates per hit. So let's select these, Control X to cut them, and go back into the tool script, the new one, and paste those in. So in addition to having a min harvest and a max harvest, I think what we are going to want is going to be a display name. So field, serialized field, public string, display name, get private set. And then we'll also have a icon specific to the tool. So field, serialized field, public sprite, icon, get private set. Each tool needs its own description as well. So field, serialized field, public string description, get private set. And then the thing that's a little bit different is we want to reference a different scriptable object inside of this scriptable object. So that's going to be the tool type. So let's do field, serialized field, and then public tool type, type, I suppose, get private set. Lastly, we need the asset menu. So create asset menu. File name is going to be, of course, tool, and then comma menu name, which is going to be gatherer top-down RPG / tool. And if you want, you can change the min harvest, max harvest. I guess by default, I'll just default those both to 1. And that'll be something that you just customize for yourself for each tool. So let's go back out to the main game menu. Let's right click in the tools folder and I'm going to create a new tool. So gather top-down RPG tool. And the tool is going to be _axe and then _copper. The reason I'm doing that is so that if we sort by axe, then all the axes will be listed alphabetically, and then we go to the subcategory of copper, silver, gold. So let's add in the tool axe. So now let's add the details. So this is going to be a copper axe. The icon is, of course, going to be the copper axe. The description can be basic axe for harvesting wood resources. And the tool type, let's select here. We can select from the other tool types we already defined. So we want tool type axe, min harvest 1, max harvest. Let's set that to 2. And now we can duplicate this a couple times. So Control C, Control V. So now with these new types, let's add in silver. And then for the third one, let's add in gold. So for the silver axe, we can say that this is display name silver axe. The icon is axe silver. And this will be a intermediate axe for harvesting wood resources. And let's say max harvest 3. And then we go to gold. Same story, gold axe, icon, gold axe. And this will be a advanced axe for harvesting wood resources, still tool type axe, and the max harvest can be 4. So all 3 of these different axe tools are still the axe type. So if we need a axe type in order to harvest a tree, it's going to work with any of these if we assign those to our harvesting component. But let's add in a type of pickaxe as well. So I'll just Control-C, Control-V, copy the tool axe copper, and let's rename this to be tool pickaxe copper, and name it accordingly. So copper pickaxe as the display name, the icon, search for pickaxe, pickaxe copper, and then this will be a basic pickaxe for harvesting stone and ore, and then the type will be pickaxe. The min harvest, max harvest can be 1 and 2. I think that's fine here. Okay, so now we have 4 tools that we can assign to our character, and we have 2 tool types. So for the gatherer tool node, we have that harvesting script. Let's edit that some more. So we removed the min harvest, max harvest, and we need to replace this bit with the tool reference. So at the top field, serialized field, and we're going to have a public tool, and we could call it just tool here if we want, or equipped tool, whatever makes sense to you. Get private set. And when we are using the amount to harvest, we're going to reference the values on this tool that's set in this script. So instead of min harvest, tool.min harvest, and then tool.max harvest. Okay, so that will help us for determining how much resources get harvested, but now we need to check to see if we're using the right type of tool. So for that to actually work, we need to define what the right type of tool is on the harvestable game objects as well. So let's right click on harvestable and go to definition, and let's set in for the harvestable script what the tool type which can harvest our nodes is allowed to be. So I can add this field up at the top, field colon serialize field public tool type, and this will be harvesting type, get private set. So for the harvesting type check, we can either put it into the harvest function, or we can put it in the harvesting script, or we could put it in both of them if we want to double check to make sure that our tool's tool type and the harvesting type set on harvestable match. So if we want to do it on harvesting script, then we add in an extra condition for the if statement, and that is going to be and harvestable.harvesting type equals tool.tool, or what do we call it? Tool.type. And then that will prevent us from going to the harvest function unless the types match. Alternatively, if you want to check on the harvestable script and make sure that no matter what script going into it, that we only allow the harvest to work if the tool type is correct, we can add an extra field to the harvest function. Or we can make the harvest function private and then have a try harvest function, which would return true if it was successful or false if we had a Boolean. So if you want to do things that way, then let's take harvest and make it private. And then we'll make a public function here, public void try harvest. And we'll have the type going into here be tool type, harvesting type, and then the int amount to try to harvest. So if the harvesting type is equal to harvesting type, the one set in the property up at the top, then we're going to harvest the amount and we'll return true if that's the case. So make sure that your return value is a Boolean. Otherwise, we're going to return false. Okay, so by having this try harvest will basically prevent us from accidentally harvesting a node without having the proper tool type equipped. So let's now go back to the harvesting script and change this to not harvestable.harvest, but harvestable.tryHarvest. And then we'll pass in the tool type from the tool. So tool.type, comma, amount to harvest. And with this being the case, we don't really have to have this check anymore. So I'll just go ahead and remove that actually. And then this should basically achieve the same thing. So the tryHarvest function essentially checks the tool type to make sure harvesting the node is possible before harvesting the node, and returns true if the node was successfully harvested, or false otherwise. Okay, so now that all that is done, we can go to the harvesting script and we can set what our current equipped tool is. So let's set up tool axe copper. And then let's take a look at the prefabs for the large rock and the tree pine. And let's jump into those. So the large rock resource node needs a harvesting type. So this should be Pickaxe. And let's go back out to the scene and look at the tree pine node. So I'm going to expand this resource node. And then let's change the harvesting type to X. So let's go to the main scene once again. If we look at our player, we can see that the tool set here is the copper axe tool. So this is what's equipped. Let's also apply this to the prefab as the default tool to be equipped. So I'm going to click on the 3 dots at the top right of harvesting, go to modify the component, apply to gatherer. Now we can hit play and we can test if this works. So let's try harvesting the axe. I'll go up to it, hit F. And you can see that harvesting the rock with the axe does not work. And that's even though the polygon collider is getting churned up. You can look at the scene view, click on the rock, and you can definitely see that the collider is there. So it's successfully preventing us from harvesting the rock. Now, if we go down here to the tree, let's harvest it, and you can see that it is still able to harvest. Okay, and let's try this tree. Okay, I guess got to go down a little bit. Yep, it's working still. And this tree down here as well should work. Now, to prove that this works with other types of tools as well, the scriptable object tools, let's try dragging in the tool pickaxe copper into the gatherer's tool object. So click on gatherer tool in the hierarchy and change the tool to tool pickaxe copper. Now the sprite hasn't changed here currently, but we should be able to harvest the rock. So let's go up here and hit F, and you can see we're harvesting the rock because the harvesting script recognizes us as having the pickaxe tool equipped. So we can keep hitting F, and that's working really well. So this might end up being the last video in the Gatherer top-down series, at least unless I add some bonus content. What we're going to do in this video is make it so that we have a simple UI for swapping out the tool on our harvesting script by clicking buttons on the screen to select the right tool, equip that to the harvesting script, and also update the sprite renderer whenever this tool property is set in the harvesting script. So right now we can still harvest our trees, we can collect all the resources. But one thing I did notice is that sometimes when we're picking up the resources on the gravity script, it will make the tracked objects actually null there because they're removed from the scene. They no longer exist, but the list hasn't been updated. So in order to solve that, I will remove any existing null resources from the list of resources before we go in here to this for each loop and translate each of the valid resources. So before the for each, we're going to do underscore nearby resources dot remove all, and then we'll do x is not equal to null. Oh, actually, wait, hold on. We want that to be equal to null. So we remove all of the null resources. So this x is the parameter of the resource pickup being passed into this lambda expression, where we're grabbing all of the x, which is resource pickup, that are equal to null. And you know what, actually? It would probably be a lot more clear if we rename that parameter to pickup. So we're removing all of the pickups where pickup is null before we go into this for each. So we guarantee that at this for each loop, all of the pickups still in the list are valid. So that should clear up that issue where occasionally you'd have the null pickup but still being tracked in that list of pickups. So now as for swapping out with the UI, first I want to jump into the harvesting script. So let's edit the harvesting script. And what I want to change here is on this tool property. Right now we just have a simple private setter function, which means that we'll set the tool, but nothing else happens. But with a setter function or getter function, you can add extra lines of code, meaning that whenever the tool is set, something else is going to run. Now, this does mean that we can't have the automatic backing field, so we'll need to change the script up a little bit here. So below the tool property, I'm going to have a private tool field, and I'll call this underscore tool. So this is still the field. We can serialize it in the inspector if we want with serialize field. You don't need the field part because this is already a field. And now we can set a custom getter and setter function. So let's redo this bit here. I'm going to do get, and the get is going to return underscore tool. Okay, and then set, which I want to make a private set, is if the value being passed in is not the already existing tool. Something went wrong down here. I think we gotta finish the brackets for that to set up correctly. So just make sure you have the right number of curly braces. And then if the tool that is already set does not equal the value being passed in the new tool, then we're going to make the current tool equal to the value. But we're also going to update the sprite. So basically, whenever we set the tool, we want to update all the other objects that are dependent on that tool value. So then to update the sprite, we need to find the sprite renderer on the harvesting game object. So private sprite renderer underscore renderer. And then we can get that on start. So underscore renderer equals get component sprite renderer. And then while the game's running, we can now update it. So underscore renderer dot sprite is going to be equal to the tool dot icon. Now this would technically work, updating the sprite by setting the icon to the sprite, but I think that the tool should have another field just in case the graphics are different between the icon you're using for the UI and the actual visual that you want to use in the game world. So let's create another property here. And maybe we want to call this new field the sprite, more implying it's visual in the game world rather than the icon for the UI. So let's control period on this and generate the property. I'm going to right click on the property name, go to definition, which will bring us into the tool script. So we can serialize the backing field, just like we did with everything else. And I think I want to take this property and move it up here to where we have icon. And I want to take the set and make that a private instead of an internal. So we'll have field, serialize field, public sprite, sprite, get private set. Now if we go back out to the game world, we want to take the tools in our project and set the sprite for its visual in the actual game, which in this case is the same as the icon, but it doesn't have to be because they're separate fields now. So let's get the gold axe here for this one. Here we'll use the silver axe. And then pickaxe tool copper. So copper pickaxe. So now those tools are set up properly. So before we hit play and test things, we also want to make sure that the tool, whatever it's set to, will be the sprite display at the start of our script. So let's change the script up a little bit. First off, if we set a tool value, the tool could be null, which would mean that the sprite renderer is null, and then the sprite here doesn't exist because the renderer doesn't exist, so we'd get an error there. So we want to check if the tool does not equal null, then we'll set the renderer sprite as we were before. Otherwise, the renderer.sprite is going to be equal to null. And this is something we also want to set at the start of our script, just to have it update once outside of this tool set property. So let's take this code and turn it into its own method. So quick actions, extract method. And I'll say update. And now that we have a function, we can just take this down here and call it on start as well. So this bit right here, I'll turn into the description. So now let's summarize this function. So we're updating the sprite to show the sprite of the equipped tool. Okay, now if we go back out to the game, right now the tool is set to none. If we hit play, then you'll see that the sprite is now set to none. And if we change out the tool, like tool axe copper, oh, well, that's not going to work right there because we're setting it in the inspector. So this right here is the field. It would only change if we set the property now. So to set it using the property, we would need actual code to do that. And then now let's create our UI buttons in order to set the harvesting script using the property rather than the inspector. Okay, so in the hierarchy, let's right click and I'm going to do UI. Let's just go with button text mesh pro. In order to use Text Mesh Pro, which is the default standard in Unity nowadays, you do have to import the essentials into your project. So just go ahead and do that, which would just bring in whatever's required for the script to run. And then we have our button here. So I'm going to take the text and let's just get rid of the text from this button. And then I'm going to take the button and let's rename it set X copper button. Okay, and then we want to set the graphic for our button. So I think we changed that at the source image here. So let's change that to copper axe. Okay, and for the sprite to, be kind of more clear, let's change the width and height to be similar. So if we do 80 by 80, or let's double that, 160 by 160, then now this button is stretched to a size that corresponds with the original ratio on the image so it looks proper. So another thing we want to make sure is that our UI elements scale with whatever our screen size is. So right now in game view, if I take the resolution and I change it to something higher, like full HD, you'll see that the button shrinks correspondingly because it didn't resize with the screen. And if we go something very low, like 640 by 480, you can see that it's not scaling as well. So to fix that, we go to the canvas, which is automatically created when you add your first UI button. Take the UI scale mode for canvas scaler and change that to scale with screen size. Now just set the default screen size that you want to be the base resolution, and it will just scale accordingly based on if it's higher or lower than that base resolution. So we could try something like 1280 by 720 if we want. And then now whatever values you set here for set copper axe button is going to be roughly the size it looks on the screen, regardless of what size it is. So if I change it to 1280, then you can see it's the same size. If we shrink down to 320, it's the same size. So that is how you get it to scale up and down. Now let's add a couple extra buttons here. So I'm going to Control D a couple times. And you'll notice that these buttons don't spread out in a grid automatically. For that to happen, we need to go to the canvas. And let's right click inside of here and create a new UI panel, which will give us a background. But it can also serve as the grid component, where any buttons beneath it will spread out across a horizontal or vertical layout automatically. Then take all three of these buttons and move them into the panel. And then on the panel game object, add in a component. So I think it's a grid layout group is what we're looking for. So grid layout group. Okay, you can see that immediately our three buttons are now layered over here. But we're going to want to reposition this to the bottom of our screen. So the panel, I'm going to take this stretch thing over here and hold Control Alt and Shift down, and then click on this center bottom one, which is going to set the pivot point, the anchor point, and the position to the bottom middle. So click on that twice. And the reason nothing happened yet is that the width and height are still set to the screen size. So change this to something more like 400 by 100. Okay, and then we have something of a rudimentary hotbar at the bottom of the screen. I might change this to 300 or 325. Just find a size that looks good for you. So down here at the bottom for the grid layout group, we can kind of organize it a bit. So I think we can get the children to be middle center, which will position it halfway between the left side and the right side, kind of making it look a little bit more organized. The cell size, if you change that, that's going to set the size of the buttons. So I think that might actually override whatever we set before for the copper axe button. You can see that now the values are being determined by the grid layout group. So the grid layout group controls your button sizes now. So for the other buttons, let's change their name to be something more like Hotbar 2. And then the third one can be Hotbar 3. And then the first one, Hotbar button 1. Let's call them Hotbar button 1, Hotbar button 2, Hotbar button 3. Because theoretically, you know, when you're making a game, you might make it so that the buttons can do other things rather than just change out one single item. It might be able to change out whatever item is actually equipped to that slot. A bit more advanced than, you know, we're going into for this series. Let's take the Hotbar button 2, and for right now, we'll set the axe to be axe gold, let's just say, and Hotbar button 3. We'll take the sprite here and make it, let's say, Pickaxe Copper. Now, clicking these buttons isn't going to do anything right now if we go into play mode. So you can see we can click on them, but we do get a simple problem, which is that the action for clicking on the button is left mouse click, but it's also one of the actions we have set up for using the swing animation on our player, which is why I also added in the F key for controlling the swing animation. So that's why on our player, I'm just going to, for simplicity's sake, disable the left mouse button click for the use animation. So let's go in here to left mouse and just remove it from the use action. Okay, so if we save that, hit play, now clicking on these buttons is only going to trigger the buttons on click function. So right now the buttons don't actually do anything. So to make our buttons do something, let's add a new script. We can call it the equip tool script, create and add. So let's edit the script. In order to equip a tool, we'll need to know what tool is stored in this button slot. So do field, serialize field here, and we'll have a public tool. And for this one, you might actually want to make it a public setter function, because since it's meant to be attached to a hotbar, you might want to be able to change out what tool is going to be equipped when that button is pressed. So for now, we'll make the setter function not a private set, but a public set, which means other scripts would be able to access it and change it. We'll remove start and update, and then we'll have a function that we'll call on click. So this will be public void change tool. So to change the tool, we need to know which script we're trying to change it on. So there's a bunch of ways you can do that in Unity. Basically, we need to find the player object, and we need to find the harvesting component under it. So one way we could do it is search the scene for a player controller, and then once we have the player controller referenced, we take the game object of that and we search its children to find the harvesting script. So when our equip tool scripts start, let's get access to the harvesting script that we mean to change. So private harvesting, and we'll call this target harvesting component, or just target harvesting. Okay, so now on start, we want to get that component. So this won't be the most efficient way, because I'm just going to have it run once per equip tool script. You might have something like a manager script, which assigns the harvesting to each equip tool object in your game, so that you only need to run what I'm about to run once, rather than 3 times or 4 times. But it shouldn't honestly make that big of a difference for what we're doing here. So let's take the target harvesting, and we're going to find an object by type, and we're going to find the player controller. So theoretically, this is a single player game. There should only be one player controller. So we're going to find the player controller, and then we're going to get the component in its children, which is going to be the harvesting component. And then we're going to assign that to target harvesting. So whenever our script loads equip tool once per button, we're going to find the harvesting component on the player, and then we'll use that for assigning the tool. So you just have to get that reference once. It's better to do that something like on start, rather than getting it once whenever you call change tool and for every time you call change tool. Unless you think that the player controller and the harvesting script are for some reason going to change objects or change locations, then you might end up with a null reference just doing this. But in our game, the player is never going away, at least while we're still able to change the tools out. So we're just going to go with this for now. But just in case the player was removed from the scene or something, we can check if target harvesting is still active. So if it's not null, then we're going to change the tool on the target harvesting. So target harvesting dot tool equals the tool from this equip tool. Okay, and we can see that that tool is not accessible because it has a private set. So let's right click into the definition, and let's change the set to a public set instead of a private set. And then that will fix up that error. So when the target harvesting is no longer valid, we want to log some kind of warning. Just if we're still debugging our game and trying to figure out what's going on, this message can help us out a little bit. So we're going to say that the target harvesting component is no longer referenced. Is the player still active in the screen? Okay, so the reason I would set up this message would be that we might have a case where we kill off the player, but then we haven't taken the hotbar buttons and disabled them. So then this can kind of let us know that we're still trying to set tools or equipment items on the player, even though it's no longer active. So we might want to, in the future, disable our hotbar and all of the buttons from being able to be clicked on when the player is no longer active. So this can just kind of give us a clue when we're thinking about those kind of problems later on. Okay, so let's go back out to the game. We have our hotbar buttons, and we have the tools we can assign to them. So normally you'd have a bigger inventory system in order for like dragging tools from your inventory into these slots and setting them up there. But for our simple demo, we're just going to have the tools set up for each of these buttons off the bat. So I'm going to select the tool, copper X tool, hotbar button 2. Let's add the script equip tool, and let's select the gold axe, and then hotbar button 3. Let's add the tool equip tool, come down here and do tool pickaxe copper. So we have the items we're trying to equip to the player, and the equip tool script is going to reference that component where we actually equip the item to the player in the harvesting script. So now if we hit play, first off, you'll see that we have no tool. which is correct. So if we click on gather a tool, we have no tool, so there's no sprite showing. But if I click on copper axe, then it should change here, but it's not. So we'll have to figure out why that is. So clicking, oh, okay, of course I know. So the hotbar buttons, they haven't had the on click assigned. So expand the button script, come down here to on click, drag in the equip tool script. So we need to define what happens when the button is clicked. Go to function, equip tool, and then do change tool. So we just need that for all three of them. So hotbar button 2, add a function to call when the event runs, equip tool, change tool, hotbar button 3, add the on click function. So we drag in the equip tool script, equip tool, change tool. Okay, now let's go into play mode. We can click on the tools and they'll change out successfully. So we can equip the gold axe, we can equip the pickaxe, and cycle between these because they're updating the property of the tool on our harvestable script, which automatically updates the sprite renderer. So basically, changing out our tools now works, at least at a pretty rudimentary level. So let's test the pickaxe by swinging into here. Okay, so the pickaxe is working. Let's change to the copper axe and make sure this doesn't work. Okay, so it's still not working. The gold axe doesn't work as well. Let's finish off the rack, finishing off the rock with the pickaxe. Now let's try the gold axe. Okay, so you might remember that we had a min harvest and max harvest value set up for our tools. So the gold axe actually can harvest between 1 and 4 wood, where the copper axe can only harvest 1 and 2. So let's see if we can get 3 or 4 to spawn when we hit our trees here to demonstrate that the gold axe is actually an upgrade over the normal axe. So we hit once, we get 2. Second one is 2. Third one is 1. So we didn't get lucky there. Let's keep going till we get 3 or 4. Okay, so that was, I believe, 3 right there. Now we can only harvest the amount that's actually in the tree. So, you know, even if you roll a 4 with your random, you're still going to only get 2 if there's only 2 to harvest. And then we come to this tree, we get 2. This hit 1. Okay. And what we could actually do is just change these values in the inspector. So let's do 5 and 5 temporarily, and then hit this tree and it will die immediately. So we get 5 off the bat from our min and max harvest being a range of 5 to 5. Now, just be careful about your scriptable objects, because when you exit out of play mode, you can see that these values are still set to whatever I just set them to. So you're permanently changing the values of your scriptable object assets if you change the values, which is good if you want to keep it consistent for your game. You're updating how a item should be, but you got to be careful you don't change that during runtime unless you actually mean to permanently update it for your game, which is a very good reason to make it so that when you have these properties, that you make their setter functions private so you're not accidentally changing those values across other scripts. Otherwise, you could cause yourself all kinds of problems. So that pretty much in a nutshell is going to be the conclusion of this series. We have our harvesting mechanics working, different types of resources we can collect using different tools, which we can equip through our hotbar. From here, I would probably try adding in different kinds of terrain or objects, or maybe you can consider some enemies. I have other tutorial series on my channel if you want to learn how to add in some basic enemies to your game. But that is basically going to be the resource harvesting mechanics for a simple gatherer top-down RPG. So I hope that this tutorial series has been very useful for everybody following along. If you watched to the end, thank you very much for doing so. I know that this was quite a in-depth tutorial. So once again, if you do want to grab the scripts, the demos, the art packs, everything you see in this series, you can get that on itch.io or on my Patreon. So thank you again for watching to the end. I've been Chris, and hopefully I'll see all of you in my future video content.